Alright, so for this first one, we have that the straight metal arm of a windscreen wiper on a car rotates in a circular motion from a pivot point O through an angle of 140. So this pivot point O has associated the angle 140. Perfect. The windscreen is cleared by a rubber blade of length 46. So this is the rubber blade, ¿cierto? That has a length of 46. And that is attached to a metal arm between points A and B. The total length of the metal arm OB is 56. So that is 46, and the whole thing, as the diagram shows, is 56. All right, so you always want to do that just to make sure that all the information on your diagram, is where it's supposed to be. We understand the context, stuff like that. Then they tell us that the part of the windscreen cleared by the rubber blade is shown unshaded in the following diagram. So that means that this unshaded part, which I am now putting in purple or dark blue, is what the windscreen clears. See? Awesome. It makes sense because this guy here is moving over there and then over there. Awesome. That is how cars work. For part A, we need to calculate the length of the arc made by B, the end of the rubber blade. Now notice, I already highlighted the buzzwords, but that is something you have to do yourself. The buzzwords here would be length and arc, okay? Even if you're not so sure what an arc is, or what length we're talking about, or whatever, as long as you identify the buzzwords, you can work from there, okay? So I've already identified the buzzword arc. See, this one's huge. All right. Whenever you run into the word arc, all right, go to your formula booklet and see if you can find it. See, once you get familiar with the buzzwords and familiar with the formula booklet, you're gonna see that a lot of these problems are much more straightforward than what you think. So here's your formula booklet, and there's a bunch of stuff. There's number and algebra, functions, geometry, and trigonometry. I'm naming the topics here. See, statistics and probability, calculus. All right, there's a lot of stuff. See. But once you get familiar with it, which is what happened to me, you're going to go ahead and search for arc. See? Because you know there's an arc formula here. And it's exactly that. It is the length of an arc. What were we looking for? The length of an arc. All right, beautiful. So this is the formula we have to use. See? I'm going to explain how it works in a second. But for now, I'm going to write it down. We have length equals theta, which is that symbol, divided by 360 times 2 pi r. Okay, I'm taking this guy here. All right. Now, what is theta? Theta is the angle measured in degrees, while r is the radius. Right, perfect. So theta is going to be an angle, and r, as we just mentioned, is simply going to be the radius. Now, of what? Cierto, of what? Because there's more than one arc here, cierto? There's more than one arc, see? The exercise is asking for the arc made by B. The arc made by B, the end of the rubber blade. So that means we're talking about this arc over here. See? Now, I'm just going to take a quick moment. Some of you may not be familiar with the word or the shape arc. Okay, and an arc in buildings, especially, usually shows up like this. You have something that goes like that. Boom. See? And this would be a sort of like archway. Dale? And so what's peculiar about this shape is this sort of like half circle that goes on here. See? This part in green would literally be your arc. Okay? So in this case, the arc made by B. ¿Cierto? So what are the characteristics of the arc made by B that I'm putting in red? Well, this is the length, and its origin is here at the bottom. See? So that means the angle I'm dealing with is 140. Okay, so L equals 140, I'm putting in for the angle, ¿cierto? Divided by 360 times 2 pi r. Now, I need to find r, ¿cierto? What is the radius? Now, the cool thing about an arc, okay, and about any arc, is that it's part of a circle, okay? It's a circle that is almost complete. It's half of the circle, a third of the circle, whatever, see? And so in this case, ¿cierto? The rest of the circle would look something like this, all right? And so what's cool about these exercises is that this that I'm putting now in yellow, let's say, looks like what? It looks like the radius of my circle. See? This that I'm putting in yellow over here looks like what? Looks like another radius of my circle. See? And so that is the sort of stuff that we're dealing with. And so with that context in mind, finding the radius is suddenly much easier. See? So the radius would be this distance that I'm now putting in, let's put it in black. See? So this distance here is going to be my radius, which is the same as this distance here, which by context of the problem is 56. So my radius is going to be 56. And now I can go ahead and plug this into my calculator. See, if you plug it into your calculator, trust me that you end up with, give me just 1 second, you end up with your length being equal to 137. Don't forget your units, centimeters. See, if you want, yeah, I'm just gonna leave it like that. See, 137 centimeters. So that is for part A. For part B, you need to determine the area of the windscreen that is cleared by the rubber blade. All right, interesting. So now we're working with area. And so we go to my formula booklet. What the hell is going on with arcs and sectors? The area of a sector is right here. All right, interesting. So a little bit of context, okay? If you want to understand this very intuitively, what's in, let me erase this for a second. If you want to understand this very intuitively, this in red, okay, would be like the length of arc, the length of my arc. And here that I'm going to put in this bright gray, ¿cierto? Everything that's inside, including this here, okay? Actually, I'm going to use another color so it's super clear. So all of this, including this little circle here, would be the sector of my arc. And so because I need to find what's just in white, what I can do is find the area of the sector in green, find the area of the sector that I'm now going to put in red, subtract the two, and end up with what's white. See? So basically you take the big sector, subtract it by the little one, and you're going to be fine. All right, I think my diagram was not as clear as I would like it to be. So let me explain it one more time. We're going to take this guy, find the area of that, and subtract it to this guy. And that way we end up with what's in white, okay, which is what part B is asking for. So for the big guy that I just drew in red, ¿cierto? For part B, the big guy in red, all right, has to use the following formula. So we have that A equals, I'm looking at this one here, A equals theta divided by 360 times pi r squared. See? So of the red guy, we know that the theta has to be 140. See, it's just like part A, nothing has changed there. For r, ¿cierto? It is actually the same as part A, ¿cierto? It's going to be this 56. So we're going to go ahead and plug in 56 for r. See? Times 56. R has to be squared, so we're going to go ahead and put it squared on this 56. And so this thing in red, okay, we need to subtract it, all right? We need to subtract it to what we have for the guy in brown, ¿cierto? Which is this one here. So the arc in brown is also going to be 140 degrees, also divided by 360. But my radius is a little bit different, see? So my radius, ¿cierto? Of the smaller one, right? What might that radius be? Well, looking at this exercise here, basically the radius of this guy, ¿cierto? Of the little one, is the small distance that travels over there, see? So what is that distance there? Well, we know that the entire thing, ¿cierto? Is 56, and from A to B is 46. So I can do 56 minus 46, and that gives me the distance of the radius of the small guy. See, it's just going to be 10. So here I have 10 squared. And so now when I subtract both, ¿cierto? I use parentheses so that I don't mess it up. You put it into your calculator, and I assure you, you are going to end up with 3,710, do not forget your units, centimeters. Now, here I made a mistake on purpose, see? It's not centimeters like this, it is centimeters squared. So quick class, when you have centimeters to the power of 1, it's going to be distance, okay? Which is what was in part A. to the power of 1 is the same as just putting centimeters. Centimeters squared, okay, is going to be area, and centimeters cubed is going to be volume. All right? So that is a general idea of when it's squared, when it's cubed, when it's to the power of 1. Anyways, that is for number 1. All right, for this next one, we have that a group of 130 applicants, okay, applied for admission into either the arts program or the sciences program at a university. The outcomes of their applications are shown in the following table. All right, so just so that we understand what's going on here, to read the table, ¿cierto? Those that got accepted into an arts program are 17. Those that got rejected to a sciences program are 64. All right, that is how you read the table. So for part A, we need to find the probability that a randomly chosen applicant from this group was accepted by the university. All right, so the cool part about this problem is that it is super visual. See? So when you have a table like this and you're dealing with probability, I think the visual aspect for you visual learners out there is going to help a lot. See? Now, the thing about probability in general, okay, is that you need to really focus on the following sort of concept. See, when you're searching for the probability of something, you always have the part and then you have the whole. Okay? Really think about what is the part of the whole you're trying to go for. See? And so the quote unquote whole, okay, my total is 130 applicants. All right, so we're going to start there. So for part A, ¿cierto? The probability has to have 130 on the bottom, okay? Because we are snatching someone from either of these four, ¿cierto? From the whole group, from the 130 applicants that we have. All right, cool. Then they tell you that they were accepted. See, so which ones were accepted? These two, right? Because we're looking at the accepted column, the ones that were accepted with 17 and 25. So I can go ahead and put 17 plus 25 over here, and I end up with 42 over 130, which is roughly 32.30%. So that is for part A. See? Really keep in mind the whole part over whole thing. Then it gets a little weird. They tell us that an applicant is chosen at random from this group, and it is found that they were accepted into the program of their choice. So for part B, right, we need to find the probability that the applicant applied for the arts program. Now, the hardest part about probability is thinking how to approach the problem. See? And so initially, ¿cierto? We had an applicant that is chosen around from the group, right, for part A and was accepted, right? Here, we have that someone was chosen from the group and they were also accepted, see? And we need to find the probability that of these guys that were accepted, they applied to the arts program. So I'm going to say that again. Be very careful about what I'm saying, see? The guys that we're looking for, ¿cierto? My new whole, okay? It's not the 130. It's the ones that were already accepted. See? So of those that were accepted, how many are in the arts program? Ah, so my whole, ¿cierto? Is what I'm going to put now in purple. Of those that were accepted, how many were in the arts program? All right, so keeping that in mind, of those that were accepted, we have 17 plus 25 divided by those that are in the arts program, which is just 17. So this is going to be 17 over 42, which is roughly 40.47%. See? So again, it's really hard to approach this problem because how you think about it is the key sort of thing. Okay? For part B, you really need to identify that there's a new whole, ¿cierto? It's less than before. It's not 130 anymore. It's only the ones that were already accepted into something. See? This right here, actually, if you want to identify it in the following way, is conditional probability. See? And the key idea, I'm going to actually pull up the formula. The key idea of conditional probability is that your whole gets changed. your hole, okay, your hole gets smaller. See? Because now we're not just looking at those that apply to the university, we're looking at those that only got accepted. See? And so actually you can use this formula as well to figure it out. I personally think it's better to approach it from a visual perspective if you can. See? So notice how in purple, ¿cierto? Is my denominator, it's my new hole, and then red is what I chose. See? Applying this visual aspect for part A, it would be like this. This is my hole, and my parts were those that got accepted, so just these two. See? All right, having that in mind, let's move on to part C. They tell us that two different applicants are chosen at random from the original group. Find the probability that both applicants apply to the arts program. So I need to pick two in a row. See? Now, because we have two in a row, let's go one by one. ¿Cierto? So for the first one, see, or actually, let me phrase it differently. See? If I picked two that applied to the arts program, notice that it's just applied. See? Keyword applied, not accepted, just applied. The ones that applied, ¿cierto? Or my total is this whole thing. And the ones that are applied are these two. See? Because it's just arts program, right? So my part is going to be what's in red, and my whole is going to be what's in purple. So for the first guy, ¿cierto? We're going to have 17 plus 24 divided by what's in purple, which we know the total is 130. So that is going to be the first guy. See? Now, because we're talking about two guys in a row, okay, I'm going to go ahead and multiply. I'm going to explain that in a second. See? Why you multiply and when you add. All right? In probability, and when you find yourself saying the word and, it's going to be multiply. And when you find yourself saying the word or, it's going to be add. And so for part C, if I force myself to think in these like probabilistic terms or whatever, the probability that both applicants apply to the arts program means that I am having the probability of one applying to the arts program and another applying to the arts program. So notice the keyword and here. See, because I put and, I'm going to have this multiplication here. See? And what is the probability of one guy applying to the arts program? Well, it is right here. See? Now, the probability of another, ¿cierto? Applying to the arts program, a lot of you might say, it's the same thing, ¿cierto? 17 plus 24 divided by 130. And this is slightly wrong. See? Take a moment and think why this might be slightly wrong. It's slightly wrong because the second time around, the second guy you're picking, you already picked one that already applied. See? So actually what you need to do is subtract 1 from your population and from the ones that applied. See? And so I know this looks a little bit weird, but you do the math and it ends up being 41 over 130 times 40 over 129. See? So notice what the minus 1 here did. It made this smaller up top. See? So yeah, that is for part C. Notice that when you catch yourself saying and, you multiply. When you catch yourself saying or, you add. So this is going to be a very big number. But if you follow your calculator, it gives you this, which roughly is just going to be around 9.779%. So that is for part C and for number 2 in general. All right, for this third one, we have that the owner of a convenience store installs 2 security cameras, represented by the points C1 over here and C2 over there. Both cameras point towards the center of the store's cash register, represented by the point R. All right, beautiful. The following diagram shows us this information across section of the store. they tell us a little bit of more information. The cameras are positioned at a height of 3.1 meters. Okay, so that's the height over here. And the horizontal distance between the cameras is 6.4 meters. The cash register is sitting on a counter so that its center R is 1 meter above the floor. Damn, alright. The distance from camera 1 to the center of the cash register is 2.8 meters. That is this distance here. Alright, cool. So for part A, immediately they ask us to determine the buzzword angle of depression from camera 1 to the center of the cash register. Give your answer in degrees. Now, for this part, a lot of people don't understand well what is angle of depression and what is angle of elevation. Okay, those are the two things you can encounter. See? So let's say in this same example, see? Your angle of depression from camera 1 to the center of the cash register is basically, imagine you are up here, ¿cierto? You're up here, this is going to be your eyes, see? Your angle of depression is the angle that you need to take if perfectly horizontally, you keep aiming down, 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 down until reaching the point you need, which in this case is point R, okay? So your angle of depression, see, is going to be actually all of these until reaching R. See? So from perfectly horizontal until reaching R, it is basically this angle here. Okay? Kapow. That is my angle of depression. See? So this would be my angle of depression. When we talk about angle of elevation, it doesn't show up in this exercise, but I think you will encounter it when studying. Your angle of elevation from R to the camera, for example, would be very similar. It would be as if you were situated here, ¿cierto? And you have to draw lines until you reach the camera, see? So you keep adding angles, if you want to look at it that way, or degrees, until you reach the camera, see? And the moment you reach the camera, from being perfectly horizontal, this is going to be your angle of elevation, right? So that is angle of depression, that is angle of elevation, that is the angle we're trying to find, the one that's in red. All right, so take a moment, look at it, absorb what this means. See, depression is from top to bottom, aiming down, see? And the elevation is from bottom to the top, aiming up, see? All right, perfect. So that is what we're trying to find, see? Cool. So, in order to determine this angle of depression, see? It's super useful to think in triangles, all right? And so first things first, I can make a very long line over here, and I end up with a triangle over there, see? Now, for these sort of exercises, I suggest you like split up the diagram into lots of triangles, and you see how you can get information for each, okay? And so my end goal for part A is to find this triangle here, which has a 90-degree because I drew it perfectly up, right? From here to here, all the way up. And find the dimensions of that triangle and hopefully get the angle from there, see? And so how can he fill in information from that triangle? Well, first things first, this height is 3.1. This height is 1. That means right here, I have 3.1 minus 1, ¿cierto? This minus this, I end up with just this. Beautiful. How much is that? It is 2.1. All right, and from here, actually, we're good to go to find the angle of depression, see? So I'm going to go ahead and draw that triangle again, just leaving it a little bit more beautiful, see? Or actually, no, I can leave it how it was. See? I think it's going to be more intuitive. So if I redraw my triangle, I have 90 degrees here. This is 2.1. This is 2.8. And I need to find that angle over there, see? Cool. So what I suggest, see, is always work with the sine rule, okay? I know there's quicker ways to solve this, but I'm just going to show you the sine rule because I think for trigonometry, it's the way to go. The sine rule, if you look it up in your formula booklet, is right here, see? Now, notice that the sine rule works in pairs, okay? So the key word for sine rule is that it works in pairs. ¿Vale? Little a goes with big A, little b goes with big B, little c goes with big C. Now, you don't need A, B, C, ¿cierto? You can work with just these two. See, for example. But the main idea is that it works in pairs. See, so you need 4 pieces of information. Now, what are they? What is little a? What is big A? What is little b? What is big B? I'm going to show you in a second. If I go ahead and make a triangle right here, see? The intuition is the following. The angles are going to be big letters. So if this is big A, and this is big B, and this is big C, that means that little a is on the other end, little b is on the other end, and little c is on the other end. Okay? So the big letter, so big, is going to be angle, and small is going to be, exactly, it's going to be side. See? So now that we have that in mind, this is suddenly much easier to work with. So here I have a big angle. See? I have 90. So that means I can do that this angle goes with the 2.8. So I can have, following the formula, ¿cierto? Following the formula here, I have 2.8 divided by sine 90 equals 2.1, ¿cierto? Which is this guy here, going to the angle I need, ¿cierto? So I'm just going to put sine, whatever, sine x. See, and we're going to call this x. My angle of depression is now x. So how can I solve this? Well, I need to get x alone. See? So first of all, I can go ahead and cross multiply, right? So I'm going to do 2.8 times sine x. So I end up with 2.8 times sine x equals 2.1 times sine 90. All right, cool. We got to keep getting x alone. See? So I'm going to divide both sides by 2.8. That means I end up with sine x being equal to that whole thing over there. See? Now, what is next to my x? See? My x is next to a sine. Okay? And so what is the opposite of sine? It is going to be sine inverse. See? So I go ahead and do sine inverse to both sides. Sine inverse of this whole thing. ¿Cierto? That means this sign is going to go away with that sign, and I end up with x equals sine inverse of the whole thing I just put. That it? Now I'm going to explain in a second what sine inverse did, because I know a lot of people find that confusing, they don't really understand what happens, etc. Let's go with a basic example first. Let's say I have, I don't know, whatever, 3x equals 9. And I tell you, get x alone. Now some of you are thinking, bro, this is super easy. You divide by 3, right? But I bet a lot of you don't understand why you divide by 3, okay? The reason you divide by 3 is because x is being multiplied by 3. And so what is the inverse function? What is the inverse function? Function of multiplication. See? The inverse function of multiplication, in order to get x alone, is going to be divide. So we divide by 3, ¿cierto? Because it is the inverse function. All right, so x would equal 3. Down here, it's no different. What is the inverse function of sine? The inverse function of sine is going to be sine inverse, quite literally. And so when you do that, that is how you certify that you get x alone. See? So x is going to be equal to that whole thing, and x you will find equals just about 48.6. Cool. So for part A, we find that that angle there is 48.6 for part A. Boom. For part B, we need to calculate the distance from camera 2 to the center of the cash register. So, the distance from camera 2 to the center of the cash register is this line here. Alright, so, much how I mentioned earlier, okay? The hard part, alright, of these exercises is getting the dimensions of the triangle that you want. And for that, you need to identify which triangle you want. So the triangle that I'm looking for is going to be this one here. See? The one that I'm putting in green right now. So I know that I have 90 degrees here. I know that this side is 2.1, but I know nothing else. So what can I do from here, ¿cierto? To get the dimensions that I'm looking for? All right, so I do have this original triangle over here. See? Always look up at the tools you have, ¿cierto? And work from there. Because I know these exercises can get messy. But if I'm looking for this triangle here, ¿cierto? I need to find all the information I can elsewhere to try to fill it in. All right. So right now from part A, I identified this triangle on the left side. See? And usually what you do in part A helps for part B. So let's finish getting the information on this triangle. See? What is this side up top? Which would be this side here. See? What is this side up top? Well, I can use the Pythagoras theorem. See? Pythagoras theorem tells me that a squared plus b squared equals c squared. This is in a triangle where you have a and b and c like this. Notice something very important. Your c, okay, is always going to be the one that's alone, okay? That is because your c is your hypotenuse. That is fancy math language for the long side, okay? Your c is always going to be alone. So that being said, my triangle, I'm just going to draw it up here. So my triangle was 2.1. Here I have 2.8. Here I have an angle, and here I have 90 degrees. See, this angle we said was 48.6. And so if I embark upon the mission of finding this right here, ¿cierto? Is it A, is it B, or is it C? All I need to identify is that it is not C, okay? Because C is the long side, as I mentioned earlier, and the long side is 2.8. So I'm going to go ahead and put 2.1 squared plus my question mark squared, okay, equals C squared, which is 2.8. See? Cool. So let's go ahead and get my question mark alone. See, so I'm going to end up with 2.8 squared minus 2.1 squared equals my question mark squared. All right, so my question mark right now, ¿cierto? It is squared. See, so what is the opposite of squared? It is going to be square root. So I go ahead and square root to both sides. Once I do that, I end up with just my question mark equals square root of 2.8 squared minus 2.1 squared. Cool. I end up with question mark being equal to just about 1.85 meters. All right, so I know we're far from completing part B, but I now got another piece of information that helps me fill in my diagram. See, for these exercises, it can get messy, okay? That means you want to get all the information you can and just sort of go from there, honestly. So if this is 1.85, how does that help me? Well, it tells me that this is 1.85. Ah, interesting. Does that give me what this is? Heck yeah, it does. If you go ahead and do 6.4, which is this whole distance, minus 1.85, which is what I just found, it is going to give you 4.55. And so this distance here that I'm going to put in yellow, see, this is 4.55. All right, cool. If that is 4.55, that means that up here, I also have 4.55. Ah, I'm getting somewhere. And so now suddenly, ¿cierto? I have this triangle that I'm going to draw out, ¿cierto? I have this triangle here that looks like this. I have some space down here, so I'm going to do part B. Suddenly, I have a triangle that looks like this. I have 4.55, 2.1, and 90 degrees here. And what do I need to find? I need to find the distance that I'm now putting in red. All right, cool. So now I can use a squared plus b squared equals c squared, see? Now this thing in red that I'm going to call y, okay? Is it a, is it b, is it c? It's the long part, ¿cierto? It's the part that's alone. If it's the long part, it's the one that's alone, see? So a, I'm going to call it 2.1. B, I'm going to call it 4.55 equals y squared, see? Because it's the hypotenuse, it's the long one. ¿Dale? So to get y alone, I do square root to both sides. That means this goes away with this. Kapow, kapow. I end up with y equals square root of 2.1 squared plus 4.55 squared. All right, cool. That means that y is just about 5.01. Around there, see? Don't forget your units, meters. And so that would be for part B, the distance from camera 2 to the center of the cash register. Now I know some of you are thinking, bro, how did you know that that was the order in which you had to solve it? And my answer is brother or sister or anything in between. Um it's not so much about what is the fastest order or what is the quickest way or stuff like that. It's about identifying which triangle you need and doing everything you need to do to get there. See? And if you're not sure from where to go, just fill in information. So fill in information from your diagram, filling lengths and angles, and eventually you're going to find a way to get to the triangle. See? Now, once you get a little more creative, you notice like, if I get this, that gives me that, ¿cierto? And if I get that, that gives me this. And then you can sort of do a plan, see? But that comes with practice, okay? That comes with training your eye, which just comes with doing more and more problems, ¿cierto? But the intuition I can give you for now is find all the information you can. See, it's not easy, all right? But the more information your diagram has, the more things are going to come to your brain, and the more likely it is that you're going to find the way to get to the triangle you need. See? So your compass, okay, the way to approach this problem, your compass is identifying which triangle you need, and then doing all you need or all you have to do to get all the information from that triangle. See? So first of all, identify the triangle, and then start finding sides and angles and stuff. If you're not sure how to get there, just find angles and stuff. You'll get creative. It'll work out. See? Cool. That is for part B. And for part C, it gets a little funky. See? It says that without further calculation, determine which camera has the largest angle of depression to the center of the cash register and to justify your response. All right, interesting. So it's without further calculation, so we really have to understand and think about how an angle of depression works. See? Now, you can look at it this way. See? Imagine you are standing here. Oh, look, it already has eyeballs. Cool. You're standing here, see? And you're trying to figure out if your angle of depression is bigger to, I don't know, an apple or a tomato, ¿cierto? That is right here, or to, I don't know, a flower that is over there, see? Now, this tomato is very close to you, see? And so if you want to look at this tomato, you actually have to look down, see? If you want to look at the flower, it's farther away, ¿cierto? You don't have to actually tilt your head. You don't actually have to move your neck. And so knowing that angle of depression, ¿cierto? Depends on this horizontal line over here. Which of the two is larger? When I look at the flower or when I look at the tomato? Clearly when I look at the tomato, see? And so once you have this sort of visual in your head, this quick diagram, ¿cierto? That you can do on the side, you realize that if the object is closer, your angle of depression is higher, okay? Because you have to tilt your head more. If you don't have to tilt your head, the angle of depression is probably relatively low, see? So now that we have that intuition for part C, it says to determine which camera has the largest angle of depression. So let's make some space here so we can see our diagram again, see? Here we have camera 1, here we have camera 2. All right, cool. So which one is closer to the cash register? Camera 1 or camera 2? Camera 1 is closer, see, because of this 1.85 that we discovered earlier. Camera 1 is much closer than camera 2, which has it at 4.55 meters. Having that in mind, and having the tomato thing in mind, if you're closer, the angle of depression is higher. So for part C, what you would answer, you would say, basically, just keeping it very simple, because camera 1 is closer to the cash register, you have a larger angle of depression from camera 1 than from camera 2. And that, ladies and gentlemen, is how you solve number 3. All right, so for this fourth one, we have that the pH of a solution measures its acidity and can be determined using the formula blah, okay? Where C is the concentration of hydronium ions in the solution, okay? Measured in moles per liter. Also, important, here it says, a lower pH indicates a more acidic solution. That sounds very important. It'll probably come by or be important later. The concentration of hydronium ions in a particular type of coffee is this number. That's moles per liter. And so for part A, we need to calculate the pH of the coffee. Now for these sort of problems, usually they throw a lot of information at you and it can be a little bit confusing. So When you face one of these, read the problem a couple of times. Okay, highlight the important words as I did just now and work from there. See? And so this guy in blue that I'm going to put now, okay, is a formula. See? It's a formula that helps us determine the pH, or in other words, the acidity of something. See? So pH equals negative log base 10 times C. And what was C again? C is a concentration of hydronium ions in the solution. And so for coffee, what is the concentration of hydronium ions in coffee? Well, it tells us here that the concentration of hydronium ions, in a particular type of coffee is this number. So this number, we can plug it in there, and we will find the pH for coffee. So pH equals negative log base 10 times C, which C in this case is going to be 1.3 times 10 to the power negative 5. All right, so I know this looks kind of nasty, but something that I can point out here that is kind of cool is that if you follow the process of in any sort of math problem, you're going to get there. See, you're going to get to the answer. And so although this looks kind of nasty, once you get to know well how to use your calculator, this is easy peasy. Okay, so the first thing I'm going to point out is that there's a negative here. See? So for my calculator, I'm going to go ahead and put a negative. Now I need to put log 10. See? Now a lot of people, what they might get confused with is that when they press log next to this 7, ¿cierto? There is no 10. ¿Vale? So logs have a base. See? This has log base 10. Sometimes it's log base 20. It changes the function just a little bit. See? Um, And the default, actually, I'm fairly sure, is that it's base 10. See, so you can just plug it in from here and it's fine. But for those of you that are a little bit nervous, like why is there a 10 there and stuff like that, I will show you a trick. You can press alpha window, hitting that F2, alpha window, and you can go to log base. See, and if you go to log base, you can plug in the 10. And then you calm your anxiety and know that you're going to do it well. See? And then this thing in parentheses, I can go ahead and plug in C, which as we see, no pun intended, is 1.3 times 10 to the power of negative 5. So I go ahead, press enter, I end up with a pH of 4.88. 60. So that is for part A. Then they tell us, okay, that a different unknown liquid has 10 times the concentration of hydrogen ions of the coffee in part A. And we need to determine whether this unknown liquid is more or less acidic than the coffee and to justify the answer mathematically. And so now that we understand how the log works, for part B, it's not that much different. So we take pH, we have negative log, we have base 10, and we multiply it by C times 10. C times 10. Why is it C times 10? Because they tell us that this liquid, this unknown liquid, has 10 times the concentration. So that's why I'm doing times 10. See? So pH equals negative log base 10 times C times 10. See? We saw that this is C, so I'm going to go ahead and put 1.3 times 10 to the negative 5 times 10. I know it looks kind of nasty, okay, but if you plug it all into your calculator and trust your calculator, it's going to be fine, see? So if I go ahead and plug this in, I end up with, well, let's see. So over here, I can do times 10. So there I have negative log 10 times C times 10, see? Beautiful. I end up with 3.8860. So my pH in this case for the unknown one is 3.8860. And from here, they're asking us to justify mathematically which is more or less acidic. See? And so a lot of people here would simply say, oh, the answer in part A is bigger, ¿cierto? So 4.88, which is the coffee, is bigger than the unknown, which is 3.8860. And they would just say, oh, okay, so that means the coffee is more acidic. Boom, I'm over, ¿cierto? Now that's a common trap, see? And it has to do with you knowing well how to read acidic levels, how to read pH. And as you see what it put in red here, okay, it says that a lower pH indicates a more acidic solution. So if your pH is lower, that means it is more acidic. And so a common trap here that a lot of people probably did is that they saw the bigger number, they assumed the bigger number meant it's more acidic. Okay, small mistake, context matters. That's why when you read these exercises, highlight the most important thing. When it tells you that a lower pH indicates a more acidic solution, and it's the last sentence of your paragraph, that shit probably matters, all right? So for part B, determine which of the two is more or less acidic. I can tell you that the unknown is more acidic because 3.8 is lower than 4.88. Is more acidic than what? More acidic than coffee. And for those of you that are a little bit nervous on how do you justify that mathematically, this part here, ¿cierto? One way you can do it is literally putting it like this. See, you're saying which number is bigger with this special sign. That right there is how you justify mathematically by saying that 4.88 is greater than 3.88. See? Another way you can do it is simply graphing it and comparing it from there. But I think this right here is way more intuitive. But anyways, that is how you solve number 4. For this fifth one, we have that a polygraph test is used to determine whether people are telling the truth or not. Okay, truth or not, but it is not completely accurate. When a person tells the truth, they have a 20% chance of failing the test. Okay, so even if you're saying the truth, there's a 20% chance that the test says you failed. Okay, because the test is not accurate. Each test outcome is independent of any previous outcome. Cool. They tell us that 10 people take a polygraph test and all 10 tell the truth. So there are no liars here in the 10 guys that took the test, but there is still a chance that the test says that they're lying. See, even if they're all saying the truth, the test can be wrong. It's a calculation error. That's the context. So for part A, we need to calculate the expected number of people who will pass this polygraph test. All right, so for expected number or expected values, the intuition is the following. See, you're going to be taking your probability of the event and multiplying by the number of trials. And so let's start with something a little more simple. Okay, let's say we are in a situation of a coin. See, now a coin has two possibilities. It has heads or tails. See, and what's the probability of getting heads? 1/2. What's the probability of getting tails? 1/2. And so I go ahead and ask you, what is the expected value, right? Or better said, expected number. See, expected number of heads in whatever, man. 60 coin tosses. Coin, coin, coin tosses. My bad. This is a math class, not a language class. So expected number of heads in 60 coin tosses. See, I'm going to be taking the probability, right, of the event, which is 1/2, and then the number of trials in this case is 60. See, so 1/2 times 60, 60 divided by 2, that gives me 30. Okay, so the expected value or expected number of heads depends on your number of trials. Okay, one thing is me asking what is the expected probability of getting heads, and another thing is that I ask you what is the expected number of times I get heads in 60 coin tosses. See, and so here the intuition is no different. See, what is the probability of my event, and what are the number of trials that I'm dealing with? So for part A, it is asking specifically the number of people who will pass this polygraph test. And so what is the probability that you pass? Well, I'm going to go ahead and say right away that it's 0.8 for passing. See? Now a lot of you are thinking, where did you get that number from? All right, so what is the probability of failing? Probability of failing is 20%. That means that the probability of passing is 80. See? And that is something very intuitive in probability that we all need to understand right now. Okay? Let's say that I am throwing a dice. Okay? I'm going to take a moment to explain this because it's super important. Okay? I'm throwing a dice. See, it has one side here, maybe 3 numbers here, maybe 4 over here. I don't really know how dice are set up. Okay? But it's a dice. See, a 6-sided dice. and I tell you that this six-sided dice is unfair. See, it is not, it's just not fair. It's loaded on one side, stuff like that. See? So that means the probability of getting 1, 2, 3, 4, 5, and 6 are all like tricky. See, they're like not fair. So the probability of rolling a 1 on this dice is 1 over 10. The probability of rolling a 2 on this dice is also 1 over 10. The probability of rolling a 3, let's say, is whatever, 3 over 10. The probability of rolling a 4, we can say, is 2 over 10. The probability of rolling a 5, I do not know. And the probability of rolling a 6 is 1 over 10. See? And so here, you can actually tell me what this number is, just by context. See? Just by context, you can tell me that this number, ¿cierto?, is 1 minus all the other probabilities. So it's 1 minus 1 over 10, plus 1 over 10, plus 3 over 10, plus 2 over 10, plus 1 over 10, which is 8 over 10. See? So that's actually going to give you 2 over 10, which is 20%. See? So that is the probability of rolling a 5 on this dice. See, how did you figure that out? Because you're doing 1 minus everything else. See? Why is it 1? You're doing 1 minus everything else because 1 in probability is 100%. Okay? And your probabilities, and this is the key idea I'm trying to share, your probabilities always have to add up to 100%. Okay? There can't be anything in between. And so if they tell you that there's a 20% chance of failing the test, you go ahead and do 1 minus that 20%, and that gives you the probability of passing the test, which is 80%. See? If this here is confusing, remember that 1 is 100%. So this is the same as 100% minus 20% equals 80%. And how do you turn a percent into a decimal? Well, 80% is the same as 0.8. See, you're like dividing by 100, something like that. See, as long as you remember that 1 is 100% and 0.5 is 50%, you can probably figure out the rest. See, what is 0.05? That's going to be 5%. See, all right, so that was just a mini class in percents and stuff like that, and why we are doing 1 minus that. See, I know it's I know some of you probably know that already, but I think it's super important to have it clear for those of you that don't. That is why you do 1 minus that. See, we call it like the complementary probability, something like that. I don't remember the fancy math language, dude. You don't have to either. The main idea is you do 1 minus that because 1 is going to be your total and you're finding the other probabilities, or the rest of it, which in this case is passing. Passing is 80% chance. There it is. Times the number of trials. Well, expected number of people, ¿cierto? Number of trials. How many people took the test? How many people took the test? 10 people take a polygraph test. Point 0.8 times 10 is going to give you 8. So the expected number of people who will pass this polygraph test is 8. That is part A. For part B, we need to calculate the probability that exactly 4 people will fail this polygraph test. I already highlighted the buzzwords. See? It says the probability that exactly 4 people will fail this polygraph test. So first things first. See? What is the probability of failing? The probability of failing, okay, probability fail is 20%. I'm going to go ahead and leave that there for now. And we need to find the probability that exactly 4 people pass. See? Now there's a couple of ways to do this, right? You can do a tree diagram, you can work with the binomial function, stuff like that. Now because we have a graphing calculator, I suggest we work with the binomial function. See? Now, why the binomial function? What the heck is the binomial function? The binomial function, following its name, see, you have binomial, see? You have a binomial distribution. And not to get like too into it, because I know it can get a little confusing, but intuition, which is what I think is the most important part, is that the binomial distribution depends on bi. See, bi, same as bisexual, is 2. Okay, you have 2 options. You need to think about the binomial distribution when you're dealing with scenarios with only 2 options. Okay, so for example, the coin toss is only 2 options. Passing or failing is also only 2 options. See? And this can extend to so many other things as well. I mean, it can extend to like, did Jimmy go to the beach or not? You know, like, what's the probability that Billy goes to the beach on a weekend? And there's like 10 weekends, ¿cierto? whatever, man. Like, as long as there's only two options, you gotta think of the binomial distribution. See? And so once you get familiar with that, and also with your formula booklet and your calculator, you will know that your graphing calculator, when you go to distribution, ¿cierto? Pressing second bars, when you go to distribution, if you scroll down a lot, you find binomial PDF and binomial CDF. Now, this is the sort of thing you just kind of have to practice, get familiar with, and stuff like that. See? But whenever you encounter a binomial distribution, first by identifying that you have only two options, ¿cierto? Heads or tails, blah, 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 yes or no. These are your two main tools. Okay, you have PDF and CDF. And I'm just going to say right away, and this is this kind of thing you should write down. Binomial PDF is for exact, I don't really know how to put it. I'm going to put it like this, okay? Exact probability. While binomial CDF is going to be from here to here probability. Look, I know this is not the most fancy math definition you're going to find, but I do think it's the most intuitive one. Okay, so for part B, it is asking us to calculate the probability that exactly 4 people will fail this polygraph test. So I identified it's a binomial distribution. I know which tools I have because I've studied a lot. I have PDF or CDF. And I know the intuition, ¿cierto? That PDF is for exact probability, ¿cierto? The first one on my list. So I'm going to go ahead and press PDF and see what it asks for. So it asks for trials, a p-value, and an x-value. Paste is the same as enter. So trials, well, how many people do we have? We have 10 people, ¿cierto? Taking the polygraph test. So this is going to be trials. Cool. Trials is going to be 10. P-value is just probability, ¿cierto? And since we're talking about failing this polygraph test, well, this is probability of failing. So this is going to be my probability in this case. Bada bim, bada boom. What is 20% in decimal? 0.2. And my x value, and this is where a lot of people are like, what the hell is my x value? Your x value is when it says exactly 4 people. 4 people will be your x value. See? So your x value is the exact amount of people that they're asking for. So I'm going to put 4 here. Go ahead and press paste. Boom. It gives me that number. See? I know it looks a little weird, but let's write it down. So for part B, our answer was 0.0880. Now, what is this in percent? Well, you go ahead and multiply it by 100. Okay? Multiply it by 100 gives you 8.80%. So the probability that exactly, not more, not less, exactly 4 people fail this polygraph test is just around 8.8%. All right, so that is for part B. For part C, we need to determine the probability that fewer than 7 people, okay, will pass this polygraph test. So now, because I got to know my calculator, I know that I'm working with binomial CDF. See? So let's see what binomial CDF even asks for. So I go over here, I press binomial CDF, and it asks for the same stuff. Trials, P, and X value. See? The thing is, CDF is from here to here probability. See? And so for the TI-84, the binomial distribution looks something like this. Okay? And so basically, the binomial CDF for the TI-84 thinks from left to right. So that means if I put 10 trials here, and then I put the probability and my x value, ¿cierto? It's gonna find the area under the curve until you reach that x value. So if my x value, I say it's gonna be 6, it's gonna find the probability under the curve until I reach 6. See? And it thinks from left to right, which can be relevant in a moment. So, what is the probability? What is the trials I need? Blah, blah, blah. Let's find out. So in this case, okay, we have that we need fewer than 7 people, okay? And we're also talking about passing. So the passing is going to be my probability. See? What is the probability of passing? We said earlier it's 0.8. So my probability is going to be 0.8, your p-value. And fewer than 7 people is going to be your x value. See? Your trials has not changed. This is still going to be your trials. So I go ahead, plug in 10 here. P, my probability for passing, so this changed a little bit, for passing is 0.8. My x value is going to be fewer than 7 people. Now I know that part is a little bit confusing, so I'm going to go ahead and do like a quick diagram. See? So I have my first person, my second, my third, my fourth, my fifth, my sixth, my seventh, my eighth, my ninth, my 10th. So if I say fewer than 7 people, let's go ahead and take a moment and absorb what that really makes reference to. See? So if I have fewer than 7 people, that means I can't have 7 or more. ¿Cierto? So that means that from here to there, I have a bunch of guys that pass the test, 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 pass the test. And my guys 7, 8, 9, or 10 are all failing. Okay? So fewer than 7 people means that 6 guys, as I just showed here, this guy, this guy, this guy, this guy, this guy, this guy, 6 guys pass. All right, so that is my x value. All right, fewer than 7 people is my x value. It's going to be 6. Only the guys that pass. Boom, boom, go ahead and paste. It gives me 0.12. See, so for part C, I end up with 0.12. Whoops, sorry about that. Which is just around 12.08%. 12.08%. So that is for part C. Oh, and if any of you are thinking, how the heck do I show my work here? Because I know that the IB cares a lot about showing your process, showing your work, and all that stuff. Well, notice how the calculator puts it, ¿cierto? Up here, it literally says binomial CDF, and this is how you would put your answer. Yes, you would put your answer as binomial CDF. So there you're telling the guy grading you, yo, I'm using this function here with the parameters 10. So that means trials 10, 0.8, that means probability 0.8, and x value of 6. And just with that, they're going to understand what you were referring to. See? The whole thing of binomial CDF reading from left to right in this case wasn't so relevant. If you wanted to solve it with those that fail, you might have to do 1 minus your result. See? I don't want to get into that because it's a little more confusing, but the intuition still remains. Okay, binomial CDF reads it from left to right. In other exercises, it can be more relevant. In this case, it wasn't. But anyways, that is how you solve number 5. Alright, so for number 6, we have that the graphs of y equals 6 minus x and y equals 1.5 x squared minus 2.5x plus 3 intersect at 2.4, which is here, and negative 1.7, which is here. Alright, cool. In diagram 1, the region enclosed by the lines of y equals 6 minus x with x equals negative 1, which would be here, x equals negative 1, and x equals 2 has been shaded. See? And so for part A, we need to calculate the area of the shaded region in diagram 1. So let's take a moment, let's zoom in a little bit and see what we can do. Now, just by the look of it, okay, the entire shaded region right now could be divided into shapes. See, whenever you're trying to find the area of a shaded region, especially a region that is not just one shape, the best tool I can give you is find a way to split up that big shape into a lot of shapes. Right, that's basically what I'm trying to say. And so what you can do here actually is that you go ahead and say, all right, well, I can have one square here or a rectangle, we're not sure, and one triangle here. And so if you go ahead and find the area of this first guy and the area of the second guy and add them together, you are good to go. So for the first guy, we are dealing with a triangle. See? Now, what are the dimensions of this triangle? Well, because we know that this right here is x equals negative 1, that this is 0, and that this is x equals 2, that means that the distance, see, from this entire part is going to be what? It's going to be 3, see? If you're tripped up on that, go ahead and draw a number line, ¿cierto? This is -1, this is 0, this is 1, this is 2. What is the distance from here to here? You jump 1, 2, 3 times. See, the distance is 3. All right, cool. So right over here, it is 3. What about this distance here? Well, we can think about it the same way. So, um, let's look at my y values. See, if here I have a y value of 7, ¿cierto? That means over here I have 7. And here I have a y value of 4. That means this right here is 4. See? What is this distance over here? Which is the same distance as there. Well, 7 minus 4 is 3. So here's 3. All right, cool. So the height of my triangle is 3. So what is the area of a triangle? As you can see in your formula booklet, the area of a triangle is going to be base times height divided by 2. This is my base. This is my height divided by 2. So the area of my first guy is 9 divided by 2. All right, let's find the area of the second guy. See? So for the second guy, well, we can see that one of the sides is 3, ¿cierto? So I can already say that for a rectangle or a square, it's going to be base times height. See? So I can already say that one of the bases is 3. And now let's find the height. See? Well, this height here, ¿cierto? If this point here is 2, 4, ¿cierto? Here I have a y value of 4. That means from here to here, it is 4 units. See? So 3 times 4 gives you 12. So if I go ahead and add both of them together, ¿cierto? I'm going to have 1, the area of the first, plus the area of the second, which means I have 9 over 2 plus 12, which if I convert it all into fractions, ¿cierto? Is going to be 9 over 2 plus 24 over 2, which gives you 33 divided by 2. We go ahead and check the answer key over here. Blah, 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 blah. 16.5. 33 divided by 2 gives me 16.5. All right, cool. So that is for part A. See? Now, I'm not quite done yet, ¿cierto? I'm actually missing something. It's not just 16.5. It is 16.5 something squared. See? I would say centimeters squared, which is like the classic, but here they actually don't give us units. See? So when they don't give you units, you just have to say units squared. Now I know some of you are confused why it's squared. See? Whenever you have distance, all right, it's going to be units to the power of 1. Whenever you have area, it is going to be units to the power of 2. And whenever you have volume, it's going to be units to the power of 3. Okay? That is why it's to the power of 1, to the power of 2, to the power of 3. You usually don't see to the power of 1 because units to the power of 1, you just leave it as units. Okay? So if you were wondering, Mister, why the hell don't I see 1? Well, it's because the 1 is like hidden. See, it's invisible. Alright, whatever. Just a mini class on why it's squared, why it's not. Alright, cool. So part A, 16.5 units squared. So that is for part A. Then for diagram 2, ¿cierto? Let me just make a little bit of space. Let me leave the 16.5 up here so that we don't forget it. Oops, 16.5 units squared. Alright, so that is for part A. Now we can move on, sorry about that. They tell us that in diagram 2, the region enclosed by the curve, blah, 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 and the lines blah and blah have been shaded. Okay. Write down an integral. Oh shit. Write down an integral for the area of the shaded region in diagram 2. Alright, so before I jump into it, see, this is actually simpler than what you think, but I do think it's important for you to understand what the heck you're even doing, okay? An integral. An integral is basically area under the curve. An integral helps you find the area under the curve, see? In fact, whenever you do, I don't know, like binomial CDF or inventory or normal CDF, ¿cierto, on your calculator, all you're really doing is that when you give it an x value, see, you're asking like, all right, from here to here, what's the area? So notice it is the area under the curve, which gives you a probability for binomial and normal CDF. But at the end of the day, what binomial CDF and normal CDF are doing behind the scenes in general is that it's making an integral. See, it is finding the area under the curve in order to give you the answer. And so an integral, what it helps you do is find the area under the curve. So how the hell does an integral even work? Yeah. Um, how do you even explain that, dude? Damn. So you've probably seen in class this symbol here. Okay. So that is like the symbol of an integral. Okay, and you need to plug in A and you need to plug in B. See? Now, let me just take a moment. All right. So when you write down the integral, see, you need to write the lower bound. B is going to be your upper bound. And then you need to put the function, and then you need to write dx, which is basically saying like I am doing the integral specifically for the variable x. See? So what is my lower bound here? Well, because the calculator thinks from left to right, that means your lower bound is here and your upper bound is here. Now, how do you tell that to your calculator? Well, this line here in red is that x equals -1, and this line here in red on the right side is x equals 2. So your lower bound is going to be -1, your upper bound is going to be 2. What is my f of x? What is the function specifically that I'm doing the integral of? This guy here. 1.5 x squared minus 2.5 x plus 3. And then I need to put dx because I am doing the integral specifically for the variable x. So times dx. If you want to get really, really fancy, I would suggest you put parentheses here. See, just to keep it really clear that the dx is right outside. And yeah, that would be for part BI. See? And for calculating the area of this region, yes, you can do it by hand. But why the fuck would I show you how to do it by hand when you've got the graphing calculator? The graphing calculator, you can put this entire integral and it's going to solve it for you and it's going to be beautiful. Now, how the hell do you do that? At least for the TA84, which is the classic, you go to alpha, window, hitting that F2, and here you have a bunch of special functions. See? Here you can deal with absolute values. Here you can deal with sorry, I don't know how to say it in English actually. Whatever, like a big something. Here you have derivatives, and here you have integral. Here on the bottom you have log base. See? Today we're going to be working with the integral, the fourth one. See, so I go ahead and press it, and boom. You can notice that it's asking for the same four things that I mentioned earlier. The lower bound, the upper bound, your function, and which in respect to which variable. See? So my lower bound is -1, my upper bound is 2, my function is 1.5x squared minus 2.5x plus 3. And d of what? D of x. I'm doing the integral in respect to x. Go ahead and press enter. Boom, it solves it for you. So the area that is here, the area under the curve, okay, is going to be 9.75. Now 9.75 what? 9.75 units squared. That is for part B double I. And now for part C, we need to determine the area enclosed between both functions. Enclosed between. All right, so I know this is a math class and not a language class, but when it says enclosed between, it is literally like what is in the middle of both things. See? And so I am doing it between this guy and this guy. So what is between brown and light green? We have pink. So part C is asking for that. What is the area of the thing in pink? What is the area that is enclosed between both functions? All right, cool. So I found in part A, ¿cierto? That the area of the entire thing, which I'm going to now put in, I'm going to put it in red, see? The area of the entire thing, right? The area of the entire thing is 16.5. So what I can do is that I take the area of the entire thing, right? I subtract it to the area that I have in black, ¿cierto? Which is, it looks something like that, ¿cierto? So this minus this is going to give you the area of what is just in pink. All right? That is like the sort of idea we're going for, okay? And so let's go ahead and plug in, right? We have 16.5 for red minus 9.75 for black equals what we have in pink. And so 16.5 minus this 9.75 gives you 6.75. So 6.75 what? 6.75 units squared. So that is for part C, and that is actually for number 6. All right, for the 7th one, we have that a college, okay, runs a mathematics course in the morning. Scores for tests from this class are shown below. Blah. So this is all this is all the scores for the test done in the morning. They tell us that for these data, the lower quartile is 62 and the upper quartile is 88. For part A, we need to show that the test score of 25 would not be considered an outlier. Now, I know a lot of you are not that familiar with box and whisker plots, so I'm going to go ahead and show you how to read it nice and quick. If you already know, you can probably just skip ahead, all right? But a box and whisker plot like the one shown below, okay, the way you read it is the following, okay? This first line here, okay, is going to be what we call the minimum, okay? Your minimum score is going to be there. So what is my lowest score here? Well, it's from lowest to highest, 25. See, so your minimum is going to be 25. All right, cool. So the first line is minimum, see? The next one is your Q1. Then here in the middle, you have your Q2, which is the same as your median, okay? Notice, the same as your median. Here we have Q3, and here we have your maximum. Now, Q1, Q2, Q3 are talking about quartiles, see? Now, quartile in its word, okay, quartile in its word has the word quart in it, see? Quart should be making you think in 1/4, see? Fourth, a quart, cierto? A quartile. And so, Q1 actually makes reference to the 25% of your data. Q2, which is the same as the median, ¿cierto? Makes sense that it would be exactly half of your data. And Q3 is going to be the 75th percent of your data, okay? So that is why it's useful to think of a box and whisker plot, or why you would use it in the first place. It can help you divide, like, okay, so my bottom 25%, ¿cierto? The bottom 25% of my scores, where are they at, ¿cierto? They are here. What about from 25 to 50, ¿cierto? They are here. What about from 50 to 75? They are here. What about from 75 to 100%? They are here, okay? And that is all in respects to scores, see? So that is how you read a box and whisker plot. And for part A, they ask us, show that the test score of 25 would not be considered an outlier, see? Now there's a couple of ways to show this, see? And a lot of people would actually fall into the mistake of saying, well, it's part of my minimum, so it's fine, ¿cierto? Because in some of these other exercises, instead of showing a test score of 25, they would say 20, ¿cierto? And they would say, is this an outlier? And a lot of people would say, yes, it's an outlier because it's out of my data. But that's not really enough, ¿cierto? Like your minimum data point could be an outlier, okay? And that is where you have to like really dig in and do like a mathematical explanation for it, see? And so the following is actually not, okay, is not in your formula booklet, okay? It is how to find an outlier in a box and whisker plot. This is the kind of thing you just have to memorize or learn, okay? There's no other way you can show it. It's the kind of thing you have to know, okay? Fuck it. So how do you find an outlier for a box and whisker plot? Da-da-da-dan, like this, see? So if you're trying to go for an outlier that is in the lower end of your data, you're gonna do Q1 minus 1.5 times IQR. See, I'm gonna talk in a moment what IQR is. So this is for anything. So any number that is lower than the value you get here, ¿cierto? Will be considered an outlier. If you're thinking about a value in your upper end of your data, you need to do Q3, ¿cierto? Plus, ¿cierto? So it changes from Q1 to Q3, from negative to plus, and you still have 1.5 times IQR. So anything greater than this would be considered an outlier. See? For this exercise, we're working with the lower bound. Okay, so we are only caring about what we have up top. All right, so we only care about what is now in green. All right, so Q1, as we said, is going to be your lower bound. Okay, oh wait, that's actually something I did not mention. So when they talk about lower quartile, that is going to be your Q1. When they talk about upper quartile, that is going to be Q3. All right, so that is also important math language that you just sort of have to know. The IQR is in your formula booklet. Okay, so when you look at this formula here that you're going to have to memorize, ¿cierto? IQR is the same as IQR is interquartile range, all right? And this is just a way to really understand better how spread your data is at the end of the day. See, that's why the IQR exists in the first place. And so IQR is going to be the same as Q3 minus Q1. This you do not have to memorize because if you go to your formula booklet, by the way, the day of the test, you're walking in with your pen, your formula booklet, a graphing calculator, a whole lot of confidence, and your brain. Okay? Get familiar with the formula booklet. It's one of the tools you're going to have the day of the test. Así que we go here, we go to statistics and probability because, we're in a box and whisker plot. Page 9, here it is. Boom, there it is. Interquartile range, IQR equals Q3 minus Q1. So we go ahead and do Q3 minus Q1 in order to find the IQR. So IQR equals Q3 minus Q1. And from earlier, we found that Q3, as they told us here, is 88 and Q1 is 62. So we're going to go ahead and do 88 minus 62. 62, ¿cierto? Yep. And so that means that my IQR is the same as 26. So IQR equals 26. All right, so since we're going for an outlier that is in my lower end, ¿cierto? Because part A is asking for show that the test score of 25 will not be considered an outlier. 25 in this context is clearly in my lower end, ¿cierto? It's in my lower end of my data. I'm going to go ahead and use the formula up top, see? So we said that Q1 was 62. So we have Q1 minus 1.5 times IQR. Q1 is 62, so 62 minus 1.5 times 26. And anything lower than this is an outlier, okay? So we have 62 minus 1.5 times 26. Boom, 23. So anything lower than this is an outlier. So lower than 23 means outlier. And which number were we analyzing? For part A, they ask us for a test score of 25. Would it be or would it not be considered an outlier? In this case, we're showing that it is not considered an outlier because 25 is greater than 23 means not outlier. All right. And how do you show your work? Well, the biggest part is putting it like this and also showing how you got 23, ¿cierto? So that is for part A. For part B, they tell us that we have another mathematics class and it is run by a college during the evening. So up here we have morning. On the bottom we have evening. Okay. A box and whisker plot diagram showing the scores from this class for the same test is given below. A researcher reviews the box and whisker diagrams and believes that the evening class performed better than the morning class. So that the evening class is doing better than the morning class. For part B, they ask us that, with reference to the box and whisker diagrams, state one aspect that may support the researcher's opinion and one aspect that may counter it. All right, so let's go ahead and compare the two. See? There's a lot of different reasons you can give here, okay? But I think the most important one, once you understand the box and whisker plot, is the following, see? So as I mentioned earlier, Q1 is the 25% of your data, see? Q2 is 50%, Q3 is 75%, see? So that means that the scores from 62, ¿cierto? Over here, from 62 to, I think that's 74, okay? Here, you have 25% of your data, see? And so this 25% goes from 62 to 74, right? But if I look at the same sort of like squares, ¿cierto? From Q1 to Q2, on the evening class, ¿cierto? We can see that we have 1, 2, 3, 4, around 54 and around 82, ¿cierto? So here I have 25% of my data, right? And so what I can say from this actually is that the morning class guys, ¿cierto? The ones that are like didn't do so well in the test, ¿cierto? Go from 62 to 74. But for the ones in the evening, the ones that didn't do so well, go from 54 to 82. So there you can already say that evening class students are more spread out. And not only are they more spread out, but and also have lower scores, ¿cierto? So that is one way you can say that the evening class is actually like doing worse, see? But even then, applying the same concept, ¿cierto? For the morning class, your top sort of 25%, ¿cierto? The upper end, not the top, because here you have the upper 25, like the highest 25, ¿cierto? But one of the higher 25% parts, ¿cierto? Goes from 74 to 88, right? And the smarter kids, ¿cierto? In the evening class go from 82 to 88, see? And so actually, for the evening class, the smarter kids, ¿cierto? You can say that evening class, smarter kids are more condensed. And so when I say they're more condensed, it's like they're more grouped up, ¿cierto? Are more condensed. And so you can say that the evening class is doing better because of that. And so on and so forth. See, there's a lot of different reasons you can give. I think the more intuitive ones are the ones I just mentioned. Um, and the other super intuitive one is that you can say that the minimum for the morning class was 1, 2, whatever. I can't really see that well, but let's just say that the minimum for the morning is 25. See? What is the minimum for the evening? 18. So you can also say that evening class has a lower minimum. They are worse off. See? And so for this first one that I gave, ¿cierto? I gave that evening class students are more spread out and also have lower scores, so that I'm saying that evening is worse. See? So that actually counters, right? For the evening class, smarter kids are more condensed. This supports. And the evening class has a lower minimum, they're worse off. Counters. See? And so you can go ahead and keep listing ideas, keep listing things. But at the end of the day, it's being familiar with how the box and whisker plot is even read, and finding one reason for each is not that hard. See, I think the most intuitive ways are thinking of the minimums and how condensed or not certain parts of the graph are in respects to the other one. See? So that is what I would suggest. If you look at the answer key, they actually give like a million reasons. See? You can compare the median scores, ¿cierto? So remember the median is Q2, right? Before I compared the minimums, right? So here I'm comparing the minimums, the lowest scores. You can also compare the median scores, see? This is one I mentioned earlier. The consistency thing, I didn't mention it, but it's something you can do. The interquartile range is also something you can compare. Here they compare the Q1s. You could also compare the Q3s. Whatever, man. At the end of the day, I don't want to bombard you with all the different things you can do. But I will tell you, get familiar with how you read the box and whisker plot, and there's no doubt in me that you can definitely find one reason for each. See? I'm just sharing the ones I find most intuitive, looking at the minimums, and looking at how condensed or not they are in comparison to another one. See? I mean, from one graph to the other. Anyways, that is for number 7. All right, so we have that for number 8. A study was conducted to investigate whether the mean reaction time of drivers who are talking on mobile phones is the same as the mean reaction time of drivers who are talking, sorry, to passengers in the vehicle. Okay, so we have two things. Mean reaction time of drivers who are talking on their phone and mean reaction time of drivers who are talking to passengers in the same vehicle. Two independent groups were randomly selected for the study. Blah, blah, blah. To gather data, each driver was put in a car simulator and asked to either talk on a mobile phone or talk to a passenger. Each driver was instructed to apply the brakes as soon as they saw a red light appear in front of the car. The reaction times of the drivers in seconds were recorded as shown in the following table. So, for example, guy number one, ¿cierto? When talking on a mobile phone and I had to press brake, braked in 0.69 seconds. See, like a little more than half a second. And while talking to a passenger, it was a little less than that. See, 0.67 seconds. All right. So that is how you read the data. That is the context. That is what's going on. Here is where it gets a little juicy. Okay. At 10% level of significance, I'll explain that in a second. A t-test, I'll explain that in a second as well, was used to compare the mean reaction times of the two groups. Each data set is assumed to be normally distributed, and the population variances are assumed to be the same. Let U1 and U2 be the population means for the two groups. The null hypothesis for this test is this. Part A, state alternative hypotheses. All right, so these exercises, you guys will notice, mathematically, they're not that hard, but you do need a lot of context to know how to approach it, okay? So first things first, when we talk about a null hypothesis, okay, it's usually, it looks like this, okay? You have H0 is going to be your null hypothesis, okay? And your H1, which is what we're going to call the alternative hypothesis, is going to be the opposite, all right, of H0. Give me a second. Boom. See? So H1 is going to be your null hypothesis, and H1 is going to be the opposite of H0. That is the first intuition I'm going to share with you, okay? If you really want to get technical with it, technically H0 is that there is no change, and the alternative hypothesis is that there is change, right? It's going to make more sense in a second, but intuitively, I want you to stick with this, okay? That the alternative hypothesis is basically the opposite of HO, see? So, if for HO we have that U1 minus U2 equals 0, okay, that is the same as saying that, okay, so U0, sorry, the null hypothesis H0 is that the first mean minus the second mean is equal to 0, which is the same as saying that the first mean equals the second mean. See, how did I get there? I added U2 to both sides, okay? So the null hypothesis is basically saying, yo, the means are the same, see? So the means of the guys talking on a mobile phone versus the mean talking to a passenger like in the vehicle are the same mean. See, they're the same, like whatever. There isn't a difference in reaction time. See, the alternative hypothesis, because it's the opposite of HO, so H1 is opposite of HO. If this is my HO, which I'm going to put now in green, so that U1 equals U2, the opposite of U1 equaling U2 is simply that U1 does not equal U2. And so your H1 is effectively going to be this. That is for part A, all right? The biggest intuition I can share is that it's always going to be the opposite of the other hypotheses. And if one has an equal sign, well, what's the opposite of an equal sign? That it doesn't equal. See? That is part A. For part B, we need to calculate the p-value for these tests. See? And so when we talk about p-value is always something that gets compared to a level of significance. See? And so we're going to get some p-value plugging in the test into the calculator, and we compare that p-value to the level of significance. See? There's a general rule on how to conclude that and whatever and blah, blah, blah. But for now, let's focus on the graphing calculator. See? So you open up your graphing calculator, and you know you're working with some sort of statistics thing. See? And so here there's a button that says stat. So I go ahead and press stat. I go to tests because they tell us that we perform a t-test. And I see that here I have t-test here. See? Now, if I press t-test here, the second one, see? What does it ask for? Well, it asks for a mean, list one, a frequency, and a sort of conclusion. Now notice the list. See, there's only one list. But how many lists do I have here? Well, L1 is the one's talking on phone, and L2 is going to be talking to a passenger physically. And so here I actually have two tests. Ah, interesting. Let's go back to over here. Number 4 is 2 sample t-test. All right. So now, and I explain it this way because the day of the test, you're probably not going to remember perfectly, so you will go through this as well. You know that in stat tests, you have a whole bunch of statistics tests. See, you can see that one of these, you have t-test here, which is for one variable, and then down here you have 2 sample t-test. See, for more than one list. Here I have 2 lists. See, so I press here, I can see that I have list for L1, list for L2. All right. For frequencies, just get used to leaving them on 1. See? And for pooled, because we're drawing like, because they're similar enough where I'm getting my data from, and also because the population variances are assumed to be the same, intuitively just leave it as pooled. Okay, pooled is pretty much always just going to be yes. All right, I don't want to explain it too much because it's a little confusing. Intuitively leave pooled as yes. Okay, so anyways, I open this up, I notice that I need to fill in L1 and L2. See? So where do I fill that in? You fill that in by pressing stat and then edit. Stat edit, here are my 2 lists. See? So as you can see, I have numbers, old numbers. See? So I'm going to erase L1. How can you do that quickly? You go up, you press clear, you press enter. Boom. L1 is cleared. So I'm going to go ahead and plug it L1 here. So 69, which is this one here. 0.87, which is this one here. So on and so forth. All right, so give me a second. Bada bim, bada boom. 0.79, 0.87, 0.71. Cool. You do the same for the second list. See? I actually already did it. All right, you can double check, but I already put both lists. See? So anyways, now that you've identified you need to do the 2 sample t-test, and now that you've filled in what the t-test is asking for, ¿cierto? Which is putting it both lists. Here I have L1, L2. I go ahead and go down here. See? Now you can see here that you have U1 can either not equal U2, be less than U2, or be greater than U2. Why is it stated like this? Because this is basically what you want to put for your alternative hypothesis. See? It's literally what you're testing. Okay? And so if H0 is this here, see? Where you're gonna plug in for your calculator is this one here. Right? That's the most intuitive way I can explain it. Let's go ahead and do the test. Pooled, you leave it as yes because you're taking from a same sort of population, quite literally, and they have the same variance. So let's go ahead and calculate. See? Here I get a whole bunch of numbers. Let's focus on the ones that actually matter. See? Right now, the only one that we need to care about is the p-value. So you see the p-value right there. I'm going to write it down. See? So for part B, you have that your p-value is 0.07784. Let's just leave it at that. All right, cool. So that is the p-value for this test. Awesome. What the hell do I do with it? Well, let's see for part C. Part C, part I, state the conclusion of the test and justify the answer. So the p-value needs to get compared to the level of significance. See? And so you need to compare this number to level of significance 10%. Now, ladies and gentlemen, p-value is in a decimal. See? And the level of significance is in a percent. So let's go ahead and turn them both into decimal or both into percent. I'm going to choose to turn them both into decimal, okay? And so this 10% is actually the same as 0.1. For those of you that are confused with what I just did, bear with me for a sec. See? 1, and this is the sort of thing you just have to memorize. Okay, 1 is 100%. 0.5 is 50%. And 0.05, how much might it be? 5%. All right, you remember those three, and you can figure out any number or any decimal as a percent. If you're not sure or you want a more mathematical explanation, all you're really doing here, okay, is you're multiplying by 100. So you multiply 1 by 100, you end up with 100. See? If you multiply 0.5 by 100, you end up with 50. If you multiply 0.05 by 100, you end up with 5. See? And you're just multiplying it and putting the percent. That's how you end up with where you end up. See? All right, cool. So that's the intuition of what's going on. So this 10% level of significance is really just 0.1. And so right now, what we've identified is that this 0.07784 is less than 0.1. And so what does this mean? What is the conclusion of this? Well, when your p-value is less than p-value less than your level of significance, you reject HO. So the conclusion for part C, part I is that you reject HO. All right, I suggest, and I know this isn't exactly like the most teacher thing to do, okay, but there's a lot of things you need to know for this test, okay, and a lot of it takes a lot of effort to learn really well. This is one of the few things that I would actually suggest just memorize it, okay? I want you to get a good grade. Part of me wants you to learn as well, which I'm not going to explain right now why it's like this. But if you want to skip ahead, just understand, dude, like, if p-value is less than level of significance, you reject the HO, period. And that way you also memorize the alternative, ¿cierto? If the p-value is greater than the level of significance, you fail to reject the HO. All right? Awesome. Let's leave it at that. See? So part C, part I, we reject HO because the p-value is less than level of significance. This right here that I'm going to put now in black is enough justification for the AB. Okay, you don't have to do more than that. Part C, part I, state what your conclusion means in this context. Well, let's think about it. See, let's think about it. So HO is telling me that mean 1 is equal to mean 2. So in this context, what is mean 1, what is mean 2? Well, mean 1 comes from L1, and L1 comes from people talking on a phone. Mean 2 comes from L2, which is people talking to a passenger in the same car. And so HO is saying that both means are the same, which is basically saying that the reaction times of people talking on the phone are the same reaction times as people talking to a passenger. See? So if you reject HO, if you reject that these guys have the same mean, then you are rejecting that someone comes along and says they have the same reaction time. You say, nuh-uh, they don't. They don't because my p-value is less than my level of significance. And so what the conclusion means in this context is exactly that the means aren't the same, that it actually matters whether they talk to the phone or talk to a passenger in the same car physically for your reaction times. And that, ladies and gentlemen, is how I would suggest to do number 8. And now for number 9. Number 9 is super hard, okay? We have that the graph below shows the average savings, S, in thousands of dollars, of a group university graduates as a function of T, number of years, after graduating from university. Okay, cool. So, for part A, we need to write down one feature of this graph which suggests a cubic function might be inappropriate to model this scenario. So let's first talk about what is going on with cubic. See? Cubic is to the power of 3, okay? Squared, all right, is to the power of 2. Now, which function have you seen that has a squared on it? The classic, my guy, the parabola, see? So this here usually is like x squared plus 3x plus I don't know what the hell, see? Yeah, this is squared, all right? For a cubic, it would look something like, actually like this one, see? This one right here would be cubic. Now, why is that one cubic? It's cubic because it has this 3, okay? And so depending on whether it has a 3 or a 2, all right, it shows whether it's squared or cubic, all right? You always have to look at the biggest exponent to see if it's cubed or squared or whatever, see? So if the biggest one is 3, that means it's cubed. If the bigger one is 2, that means it's squared. And so one feature of the graph which suggests a cubic function might be appropriate to model this scenario, well, you have to ask yourself, what is a characteristic of cubic functions, see? And so, and here's like I'm first going to give you like a super mega math nerdy reason, and then I'm going to give you more intuitive ones, okay? But a super math nerdy reason is that when you look at any polynomial or any like sort of equation with exponents on it, whichever is the biggest exponent, in this case 3, tells you how many, usually, it tells you how many x-intercepts you have. And so how many x-intercepts do I have here? I have 1, 2, and 3. And so because I have 3, that means I have to have an x cubed somewhere. See? So that is a good reason to have a cubic function. See? Because I have 3 x-intercepts. If I have only 2, like in this example here, if you have x squared, how many zeros do I have? I've got this one there and this one there. Ah, interesting. And this even makes sense when you're talking about your classic f of x equals mx plus b. See, your line whatever formula thing. See, even in your line formula thing, here we have an x to the power of 1. How many x-intercepts do I have? I have only 1, and it's right there. All right, so that is a very good math nerdy reason to say that this should be a cubic function, because I have 3 x-intercepts, so then I have to have an x cubed, which makes it a cubic function. Okay, that is probably the best reason I can give you, and also the most math nerdy one I can share. Another sort of intuitive thing, which is probably where most people would go to, is that they know that the cubic function, okay, is basically like an s. Okay, that is intuitive that they have. This is basically like an s that it's on the side. See, now saying that it's an s is not gonna give you a point in the IB. Okay, it's not professional enough. In fact, even in the answer key says, do not accept S shape as a justification. All right. So how can this intuitive S shape be put into fancy math language? Well, looking at the S shape even now, ¿cierto? You notice that you have one maximum here and one minimum there. You have one maximum here and one minimum there. And so you can say that having one max and one minimum suggests that we have a cubic function, which is just another way to say that it looks like an S. I mean, let's be honest. Pero, well, the IB wants us to get fancy, so that's another option. See? I think there was one more. One point of inflection. See, I'm going to go ahead and explain that because, why not? Whatever. But a point of inflection is basically, let's say you have a graph that goes like this. See? So right here, it is growing. See? And then it goes down, and maybe it changes again. See? The moment it changes again, where it goes from growing to decay to grow, if you have grow, decay, grow, grow, decay, grow, that means you have at least one point of inflection. Okay? Because technically this graph also goes like that. See? And so your point of inflection is basically like this part here. That is the intuitive way I can explain it. You have one grow, one decay, one grow. You have one point of inflection. See? You have one period of time where it's in decay instead of grow, and then it goes back to being grow. See? All right, whatever. You find the reason that helps you best. For me, it's the S-shaped thing, and you have to just put the fancy math language that you have one max and one min. Those 3 reasons work. You find which one works for you. That is per day. Then they tell us that the equation of the model can be expressed in the form S equals all of this stuff, where A, B, C, and D are real constants. The graph of the model must pass through the following 4 points. And so these 4 points are real points. Okay, they are parts of my model. For example, 0 and -5 is right here. This point here is 0, -5. 1 and 3, I mean, I'm eyeballing it, but it's probably this. I wouldn't be surprised if it's this. It's 1 comma 3. See? 2 comma -1, it's going to be probably here. And 3 comma -5. Actually, no, I messed it up. Over here, it's probably 2 comma -1. And over there, it's probably 3 comma -5. See? Again, I'm just eyeballing it. I'm just trying to explain that these points are part of my graph. See? So you have to work thinking about it that way. All right? So the graph model must pass through those 4 points. All right, cool. And we need to immediately write down the value of d. Now some of you are probably already thinking, how the hell can I immediately write down the value of d? Well, let's look at d in this equation here. X equals at cubed plus bt squared plus ct plus d. What is special about D that A, B, and C don't share? So D, some of you probably noticed, is alone, okay? D doesn't have a T next to it. Ah, interesting. And so if you go ahead and plug in 0 for T, this point here, if I go ahead and plug in this point there, so we have S is going to be -5 and T is going to be 0. So we have A times 0 cubed plus B times 0 squared plus C times 0 plus D. Now all of these times 0, even 0 times 0, it's just going to end up being 0. So we have 0 plus 0 plus 0 plus D. So -5 equals D. That is the value of D. The more intuitive way I can explain it is that D, because it doesn't have a variable next to it, is going to be your y-intercept. See? It's going to be this guy here. This is no different than when you have, I don't know, 5x squared plus 7x plus 2. And I ask, what is the y-intercept? A lot of you know this by heart, by memory. See? Oh, you say, oh, it's 2. But maybe you don't really get why. Okay? That's because in the y-intercept, all y-intercepts have the point 0, y. So if you plug in 0, y, you're going to end up with y equals -5 times 0 squared plus 7 times 0 plus 2. You end up with only 2. You end up with the one that's alone. You end up with the one that doesn't have a variable next to it. So the y-intercept here would be 2 because y equals 2 when x is 0. Okay? This is no different than what we did just now with point D. All right? I just want to share the intuition that because it's the only one without a variable next to it, it's the y-intercept. All right? Whatever. Fuck it. That is part B, part I. Part B, part double I is write down 3 simultaneous equations for A, B, and C. So, I just used the first point here that I haven't read to find the y-intercept, to find D. For the other 3, I can go ahead and use this one, and this one. See? Now, I will tell you right away, this exercise gets messy, and it's an exercise that is supposed to get a little messy. Okay? Point is, I have 3 points. See? I have 1, 3, which is this one here. Then I have 2, -1, which is this one here. And then I have 3, -5, which is this one here. 3, -5. They also tell us that S equals AT cubed plus BT squared plus CT plus D. Now we know that D is how much? We know that D is -5. See, from just now. So we're gonna have plus CT minus 5D. Sorry, minus 5. And so part B, part double I asks us to write down 3 simultaneous equations for A, B, and C. Okay, cool. So I have 3 points, therefore I can make 3 equations. Right, interesting. So this one right here is the same as your x, okay? And in this context, my x is going to be my t. So actually, this 1 right there is going to be t1, and this 3 is going to be s1. All right, this is no different than when I say x1, y1, okay? It's just a set of points, all right? So t1 is going to be 1, 3 is going to be s1, t2, s2, t3, s3. If you're confused, just follow the process. It's going to make sense in a second. See? So I'm going to go ahead and plug in these points into this equation here. So for the first one, okay, for T1, S1, I'm going to have 3 for S. A is not going to change. And T is going to be 1. So I'm going to have 1 cubed plus B times 1 squared plus C times 1 minus 5. So that means my first equation is 3 equals A plus B plus C minus 5. That is my first equation, and all the equations we're going to put in this purple. Okay, so that is my first equation. For the second one, okay, then I'm going to start over here. My t is going to be 2, and my s is going to be -1. I'm looking at this guy here, all right? So -1 equals a times t, which is 2 cubed, plus b times 2 squared plus c times 2 minus 5. Notice that I plugged all of these in parentheses, okay? And as a rule of thumb, when you plug in a number, plug it in parentheses. That way you can make sure you're doing it well in terms of exponents, in terms of double negatives, on all of that stuff, see? All right, so negative 1 equals a times 2 cubed. So 2 cubed is going to be 2 times 2 times 2. If you don't believe me, check your calculator. That is going to be 8. So 8a plus 4b plus 2c minus 5. All right, I'm actually going to leave it like that for now. This is my second equation, see? And now for my third one, we've got that my T3 is 3. So we have, oh, and that my S is negative 5. So negative 5 equals a times 3 cubed plus b times 3 squared plus c times 3, negative 5. I keep going a little bit. I end up with negative 5 equals 3 times 3 times 3 is going to give me 27. So 27a plus 9b, 3 squared, plus 3c minus 5. All right, and this is going to be my third one. All right, and so that right now, what I just did, is probably enough for part B, part double I. So you write down the 3 simultaneous equations for A, B, and C. And now, hence or otherwise, we need to find the values of A, B, and C. All right. And so here, what some of you might have heard of is this thing called elimination and substitution. Okay. When you do elimination or substitution, all you're really doing, and the secret to what is about to happen, is that you decrease the number of variables in your equation. All right, I know what's going to happen now is super messy. It might not make a lot of sense, but at the end of the day, all you're trying to do is decrease the number of variables in your equations, okay? So I suggest that you're very organized in your approach, okay? So first of all, let me make a little bit of space and really be organized on what you're going to deal with first, second, third, etc. See? So you want these equations to interact with each other in a way that you end up with the least amount of variables possible. See? Right now I have 3 variables and 3 equations. That means I can solve it. Cool. So this first one here, let's leave it a little more beautiful. See? So let's go ahead and do plus 5 over here, plus 5 over here. I end up with 8 equals a plus b plus c. All right, cool. So this is going to be what I'm going to call my first equation. The second equation, let's also leave it a little more nice. So this negative 5, we're going to do plus 5. Plus 5, we end up with 6. Sorry, hold up. My bad. We end up with 4. Positive 4 equals 8a plus 4b plus 2c. So this right here is going to be my second equation. And now for my third equation, just to leave it nice, I do plus 5 to both sides. And as you can see, I simply end up with 0 equals this whole thing. All right. So this would be my third equation. Again, I'm just playing around with it so that it looks a little more nice. See? All right, and now that I have it all nice and organized, see, you can see that my first equation, I literally called it number 1. Then my second one, number 2. My third one, number 3. Okay, now that I have it all nice and organized, you can really approach this problem in a methodological way and solve it easily. Okay? And so how can we do that? What are my tools? My tools, okay, are elimination and substitution. If you don't know substitution, if you don't know what those are, you're about to discover, don't worry. And your compass, okay, or your intuition, if you want to call it, is that you will do stuff, okay? I'm actually going to put it that way. You will do stuff in order to decrease the number of variables within your equations. So for example, right now, see? Right now, you can see that I've got over here, say, all of these 3 have A, B, C. A, B, C, A, B, C. Are going to notice in a second that that is going to change, all right? And the more you decrease the number of variables, the more you will get there, see? And because it's easy to get lost, all right, a way that I'm going to suggest for solving this is that you want to target the second equation. All right, it's going to make more sense what I mean by targeting the second equation. Again, this is just my way of approaching these problems. You've probably got your own. Do what works best for you. See? So I'm going to go ahead and take this first one. I'm going to write it down again. I have 8 equals a plus b plus c. And I'm going to do substitution. See? So that means I'm going to have one of these equations and substitute it into the other one in order to solve it more easily. So let's say I want to get a alone. See? So for getting a alone, I do minus b minus c, minus b minus c. I end up with a equals 8 minus b minus c. So right now I have a alone, and I'm going to call this 1 prime. So 1 prime is going to be this here. It is a equals blah, blah, blah. I call it prime just to be organized and know like, yo, this is an equation that I edited. Okay, it's modified. Again, it's just a way to keep things clean. It's just how I do it. You find your own way. So I'm going to go ahead and plug in 1 prime, okay, into the second one. So you plug in 1 prime into the second one, you're going to have 4 equals 8a. Now we know that a from substitution, ¿cierto? From 1 prime is this. So 8a is going to be 8 minus b minus c plus 4b plus 2c. And I know this looks kind of nasty, but trust the process, it's going to work out. 8 times 8, 64. 8 times b minus 8b. 8 times c minus 8c. Plus 4b plus 2c. So let's combine like terms, leave everything kind of nice. I'm going to do minus 64 to both sides. I end up with minus 60 equals b with b is going to be negative 4b. C with c is going to be negative 6c. And so this right now is sort of like an equation I have. See? Now what is special about this equation? See? Notice, up here I had 3 variables, 3 variables, 3 variables. How many do I have in this green one? Ah, you have just 2. You have B and C. So what used to be A, B, and C is now just B and C. Hence the compass or the intuition I was talking about. You want to decrease the number of variables, and that way you end up with just A equals something, or just B equals something, or just C equals something, and it'll work from there. See? And so right now I sort of, and again, this is just how I like to solve it. You targeted the second equation. See? You took the first one, you edited it, and you plugged it into the second. So now we're going to take the third one, we're going to edit it, and plug it into the second one. That way we keep targeting the second equation. This is just a very intuitive way for me to explain it. You do your own, okay? So I'm going to take the third one, which is 0 equals 27a plus 9b plus 3c, okay? And so 1 prime got a alone. We're going to do that again. Okay, 3 prime will get a alone. So for getting a alone, I have 27a equals negative 9b minus 3c. So a equals negative 9 divided by 27b minus 3 divided by 27 times c. Those fractions look kind of weird, so I'm going to go ahead and simplify a little bit. This first term is going to turn to negative 1/3 b, and this second one is going to turn into, I'm pretty sure it's 1 over 9c. Yes, it is 1 over 9c. And so this here is going to be what we're going to call 3 prime. Okay? So this is 3 prime. I'm going to box it in red. And again, notice how both of my primes have an a equals something. Okay? So I'm going to go ahead and take 3 prime and plug it into 2. Thus, the target, the second equation thing I was talking about. See? Right now we're doing the thing on the bottom. We already did the thing on the top. Yep. So we keep targeting the second equation. We plug in 3 prime into the second one. See? The second one up here. So we end up with 4 equals 8 times a. Now because of substitution, a is going to be whatever that is. See? It's going to be negative 1/3 b, negative 1 over 9c, close parentheses, plus 4b plus 2c. Cool. So 4 equals negative 8 divided by 3b minus 8 divided by 9c plus 4b plus 2c. All right, so I don't like these fractions. See, so in order to get rid of the fractions, for example, I can multiply everything by 3. See, so I go ahead and multiply everything by 3. I am basically targeting this 3 here, all right? So I target this 3 here by multiplying everything by 3. I end up with 4 times 3 is 12. Actually, I'll keep going with the dark color. 4 times 3 is 12 equals negative 8b, so that fraction disappeared. Minus 8 times 3 is going to give me 24 divided by 9c plus 4 times 3 is 12b plus 2 times 3 is 6c. Now I still have a fraction going on, which I don't like, so I'm going to multiply everything by 9 now, okay? This is just a trick to make my numbers a little more pretty, although bigger. 12 times 9 is going to be 108 equals 8 times 9, which is 72 minus 24c plus 12 times 9, I think I just did that now, 108, 108b plus 6 times 9, I think it's 54, yes it is, 54c. So now I can combine like terms, so 108 stays alone over here. B with B is going to give me, so it's 108 minus 72, it's going to give me 36b. And combining the C's, I end up with, I think it's half of it, 54. It's just going to be 30. Okay, cool. So I end up with plus 30C. All right, and now, ¿cierto? I have these two sort of equations. Both of them have just B and C. And so now I can make these two green guys interact, ¿cierto? Which is what was cool about targeting, quote unquote, the second equation. Always making sure that your primes, the 1 prime and 3 prime, have the same variable being equal. So A equals something, A equals something. You plug both of those into the second one by targeting the second equation, you're going to get somewhere. See? So now I'm going to write down these two equations over here. All right? We have negative 60 equals negative 4b minus 6c. Right below, we have 108 equals 36b plus 30c. And I want to combine both of them. See? So what I can do here, just thinking out loud, I can do elimination now. See? This whole time I've been showing substitution, now I can do elimination. When you do elimination, basically, you want to add both of your equations and have one of the variables eliminate. If I do that right now, none of my variables get eliminated. But if I change the one up top by multiplying by 5, okay, so I multiply everything by 5, you're going to see that I end up with, well, negative 60 times 5 gives you, I'm pretty sure it's 300, but I just really don't want to be wrong. Okay, it's negative 300 equals negative 20b minus 30c. 6 times 5, yes, negative 30. And down below I have 108, the one that didn't change, ¿cierto? 36b plus 30c. And so now if I go ahead and add both, you're going to see that one of these guys gets eliminated. Negative 30c plus 30c, it's going to be 0. See? So what do I end up with? I end up with negative 300. Oops, negative 300 plus 108. Negative 192 equals 16b. Ooh, now we're getting somewhere. So 192 divided by 16b is going to give me negative 12. So b equals negative 12. So finally, damn, after all of that, we got somewhere. See? I know it took a long time, but if you follow the process really well, which is this whole targeting thing, okay, and keeping in mind that you want to decrease the number of variables, okay, from A, B, C to just B, C to, in this case, just B, you're going to get somewhere. See, so now I just got B equals negative 12. So here, once you get B equals negative 12, or likewise, okay, you just plug that shit in flipping everywhere, okay? So I'm going to take this negative 12, I'm going to plug it into this one, see? So 108 equals 36 times negative 12 plus 30c. Boom. How many variables do I have here? How many? How many? How many? Just one. I've only got C. Beautiful. So I just work around until I reach C equals something. So 108, that is supposed to be a 0. 108 equals 36 times 12. That's a fat number. Negative 432 plus 30C. So I'm going to do plus 432 to both sides, plus 42 to both sides. C is going to be equal to 432 plus 108 gives me 540. C is going to be equal, 30C. Divide by 30 to both sides, divide by 30 to both sides. C equals 14, 18. C equals 18. Boom. So B is 12, C is 18. Now I can plug it into the first one even. So I'm going to go into the first one with all the stuff I know now. So A is A, B we said was negative 12, C we said was 18. So negative 12 plus 18, 8 equals A plus 6, means that A equals 2. Bada bim, bada boom. We check the answer key just to double check. A is 2, B is negative 12, C is 18, ladies and gentlemen. See? So I know that was a long process and etc., but you can always solve it the same way. See? Consider the prime thing, all right? Consider attacking the second equation. In my experience, it's the best way to do it. And more importantly, the math lesson behind all of this is that elimination substitution, what's cool about it is that you decrease the number of variables, and that's what truly helps you solve this, okay? So yeah, that is for part B, part 3, finding the values of A, B, and C. And now it gets super weird. See, they tell us that a negative value of S indicates that a graduate is expected to be in debt. Okay, and we need to use the model to determine the total length of time in years for which a graduate is expected to be in debt after graduating from university. So, S is average savings. See? So if S is negative, okay, that means that you have negative savings, and negative savings means debt. So consider in this graph, where in this graph do I have an S that is negative? Because S is my Y value, ¿cierto? If I have anything above S, I mean above the 0 is going to be positive, and anything below over here it's going to be negative, all right? So depending on whether I'm on top or below the x-axis is whether it's positive or negative. So this guy right now is in debt here. Here they're in debt. From here until here, they're in debt. Later on, they're in debt from here until here, they're in debt. See? And so what part C, it was part C, right? What part C is asking for is the total length of time for which a graduate is expected to be in debt. So basically, I need to find the time from here to here and add it up, and then the time from here to here and add it up. And then they're not in debt anymore and they can live a happy life. Not very realistic in terms of debt, but whatever, it's fine. Okay? So we want to find these two values for t and these two values for t, and we can go ahead and just add everything. See? Now, there's a couple ways to solve this, and what I think is the most intuitive is using the graphing calculator. And so because I found that A is 2, that B is negative 12, give me a second, sorry. Yes, B is negative 12, that C is 18, and that D is negative 5, I can plug it in here. See? So that means that my savings function is 2t cubed plus, minus 12t squared, I forgot the cubed, plus 18t minus 5. This is an S, by the way, okay? So this is my function, all right? And because I need to find all those points here, I need to plug in 0 for S. See, because what all these points have in common is some t value and a 0 for S. Okay? So what I can do, interesting, is go ahead and graph it. See? So I can go to y equals and graph this whole thing. So I'm going to take 2x cubed minus 12x squared plus 18x minus 5. So I go ahead and graph. My graph is probably not going to look that nice. Okay, that is all right. No worries. Go ahead, I'm going to change my window a little bit. Change the zoom in particular. Zoom fit. See what happens. All right, so this window is a little messed up, but that is fine. So my y minimum, we're going to go ahead and change it to, yeah, we're going to change it to 8. Maximum, we're going to leave it at, I don't know, 3. And then these two values, let's see how it ends up. All right, so I can almost see the points I need. See, I have the first 3. I need the last one. So I'm going to change my x value, x max, to, I don't know, 6. Maybe now it works better. All right, beautiful. And so now I can use a whole bunch of calculator functions and stuff and etc. to find the zeros. See, to find these 4 points. All right. Well, I really only need to find 3 points, but to make the window even nicer, see, I can get rid of my negative x values and maybe change my y min to, I don't know, 6. All right, that makes it a whole lot nicer to work with, see? And so now, in order to calculate the time, I know that this point here is the origin, see? So this point is 0, 0. Let's find the other 3 points, see? For this first point, what I can do is use the zeros function, see? So I'm gonna go second and trace and hit that calc and press 0 because I'm trying to find the 0, see? Zeros in your calculator is the same as, quite simply, an x-intercept, see? So right now it's asking for left bound and right bound. What left bound and right bound does is that you're telling your calculator from where to like scan. See, so I want this calculator to scan from over here, right bound over here. See, then it asks for you to guess. All that guess really does is specify your calculator which 0 you want. Okay, so as long as you put your bounds well, you're gonna get it correct. The 0 over here is, give me a second. The 0 over here is 0.358, comma 0. So that is this point here. What about the next point? Well, let's do the same process. So left bound, we're gonna get it a little closer over there. Right bound over here, and guess right there. All right, so this over here is 1.83, comma 0. And this last one, okay, is gonna be finding the zeros, left bound, all the way there, right bound. We do the guess where we want it. It's around here. Boom. This right here is going to be 3.811, comma 0. All right, so basically from here to here, he was in debt. And from here to here, he was also in debt. Okay? That means that he was in debt for initially, ¿cierto? For this first part, he was in debt initially for 0.358 years. And then he was in debt for this distance here, ¿cierto? I'm going to go ahead and do 3.81 minus 1.83. All right, for finding that distance there, it's going to give me, let's find out. So we end up with 0.358 plus 3.81. That's fine. Minus 1.83. 2.338. 2.338. So basically, for this last part, Using the model to determine the total length of time in years for each grade is expected to be in depth. It is just around 2.338 years. All right. So that is for number 9. And now for number 10, we have that the masses of Fuji apples are normally distributed, okay, with a mean of 163 grams and the standard deviation of 6.83 grams. They tell us that when Fuji apples are picked, they're classified as small, medium, large, or extra large, depending on their mass. Key information here. They tell us that large apples have a mass between 172 and 183. That sounds important. For part A, we have determined the probability that a Fuji apple selected at random will be a large apple. So, first things first, see, what is a normal distribution? What is going on? So, a normal distribution, as it says here, when it's normally distributed, looks something like this, okay? It's a typical bell curve that they talk about, and the cool thing about the bell curve is that it's perfectly symmetrical, okay? So the bell curve looks like this. You have your mean here, which is like the fancy U, and then here and here you have like all the median plus one standard deviation, the median minus one standard deviation, so on and so forth, okay? And so the normal distribution, what is cool about it is that its pattern actually gets repeated a lot, um, like in nature and stuff. See, for example, if you take the mean weight of babies that are just born and you put all of them onto a graph, it's going to look a little bit like this. It's going to look like a bell curve. It's going to look normally distributed, and that helps a lot with analysis with probability. See, so that is like the cool side of normal distribution. The normal distribution shows up a lot in nature in general. Okay. All right. So, how the heck can we solve this? See, the thing is, whenever you face normal distribution, okay, you need to realize that you have three tools for normal distribution, okay, and they are all from your graphing calculator, okay. I'm gonna go over them in a second, but you have normal PDF, normal CDF, and inventory normal. I'm gonna go through the three of them right away. If you look over here, okay, in your TI-84 or something similar, and you press second vars, you hit that distribution button, okay? Why do we go to distribution? Because we're working with the normal distribution. So I hit it, and the first three are actually PDF, CDF, and inventory normal, see? So I actually have it's organized, see? The first one is normal PDF, the second one is normal CDF, the third one is inventory normal. See? So for normal PDF, the intuition, it's that you're finding the probability of a single sort of like data point. Okay, so you would use normal PDF if they're asking for like, what's the probability that you pick an apple with a mass of 180, ¿cierto? So you would be seeking for the area under the curve that's right here. See, only the ones that are 180. See, that would be for normal PDF. All right, for normal CDF, which is the one that you probably end up using way more, it's the probability of a lower and upper bound for data. Now, I know that sounds kind of like super mathy and weird and whatever, okay, but that makes reference to like, even here, ¿cierto? Large apples have a mass between 172 and 183, so if I'm looking for something that is, and let me just draw it on my graph so it's a little bit nicer, see? Here we have that our median is 163, and we need to find for part A between 172 and 183, so 172, 183. Normal CDF would help you find from a lower, ¿cierto? From a lower, which would be 172, to an upper bound, which is 183. So it would help me find this area here, see? So normal CDF, that's what it's for, see? And last but not least, inventory normal, okay? You give the probability, or in this case, it's going to be area, because it's area under a curve, and you get an X value or a data point sort of thing, see? When I say data point, I'm making reference to these numbers on the bottom, all right? That's just an intuitive way to explain it. It's how I like to explain it. But yeah, so normal CDF helps for bounds, see? Again, I mean, memorizing this that I just showed you, like, I mean, you can do that, see? But it's more important than the day of the test, ¿cierto? you understand that you have a couple tools, all right? So one of the tools is for a single data point. One of the tools is for like a bound thing, like lower and upper. And one of the tools is when you give the probability and get a value back. See? The day of the test, you're going to know you have these tools. You probably forget which one's which, okay? But in that way, whenever you open up any of these, you can just tell, ¿cierto? For example, normal PDF is asking for a single X value. So it's asking for a single data point, and it's going to give you the probability, ¿cierto? And so just intuitively knowing these tools can help you decipher which one is which in the heat of the moment. Normal CDF is literally asking for a lower and an upper. See, so then you know it's the bounds one, ¿cierto? The one that we're about to use. And last but not least, inventory normal is asking for area, it's asking for a probability. So it's going to give you an X value. See? So as long as you have the intuition of how these tools work, it's not so much about knowing the specific name and when to use which. Nah, dude. Just know that they exist. All right? Know where to find them on the calculator and you'll figure it out. See? All right, cool. So for part A, because we're talking about a between, cierto keyword between, for 172 and 183, we would use normal CDF. All right, so just as I'm following the graph here, I open up normal CDF. It asks for lower and upper. See? Now, just so that you guys know, when it says -1e 99, all right, that translates to -1 times 10 to the power of 99, all right, which is, as you may guess, a very, very small number, okay? Or a very, sorry, I worded that very wrongly. This is a very big number. See, it's a very big negative number. It's a -1 with 99 zeros behind it. Okay, it's a very, very big number. And so when your lower is a negative, basically infinity, ¿cierto? You make sure that you're capturing from the very, very edge, ¿cierto? You're going from here to here. So that's why the calculator puts it like that. It's not so different as putting -99999. See? So that might become useful later. I'm just giving the context of why your calculator does that, okay? For us, for part A, we're going to say that the lower is 172, the upper is 183, and this symbol here, the fancy U that I mentioned earlier, is your mean, okay? Fancy U is mean. And the other one that looks like that is standard deviation. And so following that idea, your mean is 163, standard deviation is 6.83. Bada bim, bada boom, paste, kapow. It gives me that. See? So, well, my graph is clearly not drawn to scale, but the answer for part A is 0.09209. Now why not? 50. See? Now I need to leave it as a probability. See? And so for the IB, actually leaving it like this, like they're going to get it, it's fine. But if you feel more comfortable leaving it as a percent, to convert this to a percent, you multiply by 100%. So I go ahead and multiply by 100. I end up with 9.2095. 0.92095%. Okay? So that is for part A. We used normal CDF because normal CDF is the one about bounds. For part B, it gets very, very weird. Okay? Then they tell us that approximately 68% of Fuji apples have a mass within the medium-sized category, which is between K and 172. So we need to find the value of K. So now you might be thinking of your tools. Inventory normal was when I would give the probability or the area and I get an X value or data point. See? So now I'm going to talk a little bit about how inventory normal works. See? So this is the current situation. I have my normal distribution. See? I have the mean that is around 163 and I know I have a value of 172 over here. See? Somewhere over here. And I have a value of K somewhere. I'm just going to say there. Okay? And we know that all of this, okay, that I am putting in red, is 68%. See? Now I'm first going to show you a mistake that people do here, and then I'm going to show you the right way. See? So a lot of people here would say, they're giving me a percent, or they're giving me an area, so I need to use inventory normal. Okay? So they're going to go over here, they're going to go to distribution, they're going to go to inventory normal, they plug in 0.68, 0.68 because it's 68%, right? They plug in the mean, which was 163. They plug in the standard deviation, which was 6.83. And they say, aha, this is my value of k. And this is actually wrong, okay? And I'm going to tell you why it's wrong in a moment. This is wrong because the way inventory normal works, okay, is that it goes from left to right. What do I mean by this? If you plug in 68% for inventory normal, that means it's going to go from here saying, okay, this is 0%, this is, I don't know, 5%, da 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 da, until it reaches 68%, see? Or something like that, all right? And so the value of k that it gives you is from left to right, see? So it assumes that the lower bound, or so to say, starts at 0. But here, for the, actually 168 would be, wait, sorry. This mean here is 163, so that means the 168 would be around there. Sorry, I just want to make my graph a little more accurate. Anyways, so it would tell you that the k value is like this one here, see? But inventory normal goes from left to right. And for part B, they tell us that the medium-sized category goes from k to 172, see? Not that it goes from 0 to 172, it goes from some k, ¿cierto? That is above 0. See, notice how this is above 0, okay? The small-sized apples would go from 0 to k, all right? But the medium-sized apples go from k to 172. And so now it's a little bit of a challenge to figure out how to get k, all right? I did want to show the common mistake first. It's not just plugging in inventory normal, okay? From k to 172 is not, k isn't, k is the lower bound, okay? If k was the upper bound, inventory normal would make sense. But in this case, k is the lower bound. So, what the heck can we do? What we would like to do, okay, which is our ideal situation, is, and it's something that gets used a lot in these exercises, which is why I'm going to show it that way, all right? The ideal is that I could take the probability of what I'm drawing now in purple, okay? If I could take the probability of what's in purple, all right? And if I did purple minus red, which is sort of like this, okay? What would I end up with? I would end up with this last little bit here that's why I'm going to put in green, see? And so if I end up with that little part in green, ¿cierto? Well, where's my value of k, right? My value of k was here, my value of k was here, and my value of k here would end up there, all right? And so if I get that area here, now the left to right works, ¿cierto? Because now I would be going from 0 to k. And so once I do that subtraction, I can use inventory normal and it's going to make more sense. I know this is a little bit confusing. I hope the colors help explain it a little better. But now I'm going to show you like the actual math that goes on. See? So if I go ahead and go to my trusty rusty calculator, I go to normal CDF, and I go from the lower, ¿cierto? 0 basically, or just put negative 999 to make sure, ¿cierto? From negative 99999 up until 172. I put my mean and I put my standard deviation. Oops. It gives me around 90%. See? And so the area under the curve in what's in purple, see, is following what I just did here. ¿Cierto? The area of the purple one, all right? The area of the purple one is 0.906. Why not? 0.62. See? And so if I do that minus the one that's in red, that by context, by the exercise, we know it's 68%. I do minus 0.68. I end up with the area of what the thing in green. See? So if I do this minus this, the 68, that gives me 0.2262. 0.2262. All right, cool. And so if I do inventory normal of that, all right, 0.2262, I plug in my mean, standard deviation, boom. There's my k value. see? And so my k value, by plugging in this in, ¿cierto? This into inventory normal, is going to give me a k of 157.86. And that, ladies and gentlemen, is how to do number 10. Now, just a quick hint, there's usually a normal distribution problem, okay? And more than memorizing what tool does what, I think it's better to have the intuition of what tools you have, okay? And then the day of the test, you kind of just go through them, you know which one to use. You open up CDF, you see that it has a lower and upper bound. Ah, it's the one about, finding the area between an area. O sea, in between something, right? You find the one that asks for an area. Ah, it's inventory normal, the one that gives me an X value. So in this case, we used it to find K. But yeah, I think it's more important to have the intuition of the tools rather than memorizing them or anything like that. See? I hope it helped. And yeah, that is number 10. All right, and now for number 11, we have an excellent derivatives problem. See? So we have to consider the function f of x equals blah. Okay, blah being this. X cannot equal 0 because x is on the denominator, and if you divide by 0, the world explodes. So part A, we have find the derivative of f of x. So first things first, all right? For f of x, x squared minus 3 divided by x, we need to do the derivative of this. See? Now, the following derivative is in your formula booklet, all right? But basically, it has to do with how to do the derivative of an exponent, all right? And so before you face, okay, or you do the derivative, I suggest that you make life easier on yourself. And if you have a variable and an exponent like we do here, put it up top. Okay, just put it up top. It's going to be easier to do the derivative, whatever. It's going to be more intuitive, etc. See? So if I go ahead and rewrite this, see, I have x squared minus 3 divided by x. This would be the same as 3 times x to the power of negative 1. See? Now, some of you are probably thinking, what the fuck? Why? See? And so let me show you a quick math pattern that I think is going to be very enlightening for some of you. So let's say I have 2 cubed, 2 squared, 2 to the power of 1, 2 to the power of 0, 2 to the power of negative 1, 2 to the power of negative 2, and 2 to the power of negative 3. See? And I ask you, yo, find all of these, okay? Now, maybe you don't know about the ones in negative, see, or even the one to the power of 0, but you do know the ones up here, see? So 2 to the power of 3 is 2 times 2 times 2, see? Which is going to give you 8, all right? Yeah, but 2 to the power of 2 is going to be 2 times 2, it's 4. 2 to the power of 1 is 2. 2 to the power of 0 is going to be 1, see? And right here, some of you are probably know it by memory, anything to the power of 0 is 1, but maybe they don't know why, see? So if I ask you to go from 8 to 4, what can you do to go from 8 to 4? Ah, you can divide by 2. From 4 to 2, what can you do? You can divide by 2. From 2 to 1, you can divide by 2 again. See? And this is a pattern that shows up with exponents. See? That is why anything to the power of 0 is equal to 1, because you divide it by itself so many times that you end up reaching 1. See? It also happens with, just a quick example, 3 to the power of 3 is 27, 3 to the power of 2 is 9, 3 to the power of 1 is 3, 3 to the power of 0 is 3. See? You divide it, sorry, it's, fuck, my bad. 3 to the power of 0 is 1. See? And again, it's the same pattern. Here you're dividing by 3, dividing by 3, dividing by 3. You end up dividing it by itself so many times that it's inevitable that you reach 1. See? So that is why anything to the power of 0 is 1. And now let's talk a little bit about a negative exponent. See? So if I go ahead and keep going with this pattern here that I just showed, and I divide it by 2 again, see? What is 1 divided by 2? It's going to be 1 half. Okay, let's keep going. Well, 1 half divided by 2 is going to be 1 half times 1 half, ¿cierto? 1 over 4. Interesting. See? 1 half divided by 2 is the same as 1 half times 1 half, 1 over 4. Okay, cool. So, 1 over 4. Let's do it again. See? Bada bim bada boom, divided by 2, you end up with 1 over 8. Alright, cool. So how does that help me with this negative exponent over here? Well, notice, ¿cierto?, that I can rewrite this 2 to the negative 1, this 2 to the negative 2, and this 2 to the negative 3. Because this is 1 half, and this is 1 over 4, and this is 1 over 8, it is the same as Well, 1 over 2 to the power of 1, 1 over 2 to the power of 2, 1 over 2 to the power of 3. And so now that you know all of this, you can make the following sort of like golden rule. Negative exponent means flip it. Whenever there's a negative exponent, you can just sort of flip it. So you can go from this 2 to the power of negative 3 immediately over to 1 over 2 to the power of 3. ¿Cierto? So you just sort of flip it, right? All right, cool. And so if I have a positive exponent on the bottom, I can flip it as well, and I end up with a negative exponent up top. See, so that is all I did. I also explained why it's legal so that none of you can complain about it. And I suggest you do that first before you do the derivative of an exponent. See, you're going to see why in a second. Now, when I do the derivative of an exponent, okay, all you really need to do, and it's super visual, see, so I'm going to go ahead and explain it that way. You take this 2, or you take the exponent, see, you plop it, you put it in front, okay? Your x is still going to be there, and then you do the exponent minus 1. I'm going to do the same over here, ¿cierto? So I have a negative from before, ¿cierto? Then I have a negative, I have a times negative 1. I have the 3 from before. I have the x, and I have my exponent being negative 1 minus 1. See? And so, well, the one on the right is much prettier. See? But on the right, you can see what the derivative of the exponent actually did. See? You did the negative 1 on the exponent, and you plopped your exponent in front. ¿Cierto? So you have negative 1 times 3. All right, so I go ahead and, leave this a little more nice. I end up with 2x. ¿Cierto? 2 minus 1 is just 1. ¿Cierto? So 2x. Negative times negative is positive, so I have 2x plus 3x minus 2 to the power of negative 2. See? And if you want to leave it super fancy, this would be just the same as 2x plus 3 divided by x squared. So that is for part A. See? Cool. Then they tell us that line L is tangent. Ooh, that's a fancy word. Tangent to f of x at the point of 1 comma negative 2, and using the thing from part A to find the gradient of L. So when you have something that's tangent, okay, the most classic example would be like in a parabola or something like that. See? So when you have something that's tangent, it touches your line once, never again. Tangent. Touches your line once and never again. All right, cool. So a tangent to this parabola here, ¿cierto? Could maybe be, or a classic, ¿cierto? Is like right at the maximum. See? So here is a line that touches only at the maximum and then never again. Another example could be maybe a tangent that goes like that, ¿cierto? Boom. It crosses here, it touches there, and then never again. See? So that would be the idea of a tangent. See? And so the cool thing about a tangent, ¿cierto? Is that contrary to this quadratic that I just drew here, ¿cierto? The tangent is a straight line. See? The tangent is a straight line. And so when they ask for the gradient, okay, gradient is the same as slope. See? And so how can finding the derivative, ¿cierto, of f of x help me find the slope of line L? Huh, interesting. So originally, ¿cierto, before we did the derivative, okay, here you have x, here you have y, see? In your like number line, in your plot, see, you have x and y. And so when you plug in something for x, you get a value for f of x, see? Let's remember that f of x is the same as y, see? So let's say that here I plug in, I don't know, 1, and you get a point, ¿cierto? You get that, if you plug in 1, you get 2, you get that set of points, 1, comma 2, see? It's just an example. If you plug in 2 here, here you get 3, it's another set of points, 2, comma 3. When you do the derivative, this actually changes completely, see? Because now when you plug in x and you get a value for the derivative of f of x, it's a little bit different, see? What actually changes? So now, okay, x is still going to be like an x coordinate, okay? X is still an x coordinate, but derivative f of x, see, is now basically going to be slope. That is now slope. It is now rate of change. And so to find the gradient of L, okay, using the part from part A, which is this here, see, all you have to do is notice where does line L touch f of x. And they tell us that line L is tangent to f of x, so it touches once at the point 1 comma negative 2. So if I go to my derivative for part B and I plug in 1, I am asking the function, see, before we do the math, okay, I am asking the function right here, when my x value is 1, what is my slope? What I used to ask before is, when my x value is 1, what is my y value? Now that I did the derivative, when I plug in 1 here, it's, when my x value is 1, what is my slope? So when my x value is 1, my slope is 2 times 1 plus 3 divided by 1 squared, which is the same as 2 plus 3, which is the same as 5. So the gradient of L is 5, period. That is part B. I think the biggest thing to understand is how the derivative changes, like what you plug in, what it means, and stuff like that. See, remember, right here, this is super important, man. When you plug in 1, in this stage over here, you're asking your function, what is my slope at x equals 1? Okay? Once you have that in mind, it's actually super easy to solve the rest. See? Or these derivative problems in general. And now for the hardest part, as you can see, it's worth 3 points. We have determine the number of lines parallel to L that are tangent to f of x, and to justify our answer. All right, so basically, our line L has a slope of 5. And there are infinite lines that have a slope of 5. And so which of those lines also touch f of x that need to have a slope of 5? See? Let's remember what parallel means, okay? Parallel is when your lines are like this. Okay, they never touch. That means they have the same slope. M1 equals 2, M1 and M2 being slopes. See? So these would be parallel lines. The other word you might be thinking of is perpendicular. Okay? Perpendicular is when they're literally like crossing each other. See? Like that. Or maybe like this. Alright? And perpendicular slopes have work in the following way. Like the first slope times the second slope is going to be negative 1. See? What does this imply? It implies that 1 is the reciprocal of the other. See? It's the flip times negative 1. You might know it that way. See? Now, I'm not going to get into perpendicular slopes because that's not the issue here. But just so that you know, or you have the math language here, that you have parallel lines, you have perpendicular lines. That's the gist of it. See? So parallel lines is the same slope. All right? So determine the number of lines that have the same slope to L that are tangent to f of x, and to justify our answer. All right, so I just found out that the slope is 5. See, when x is 1, the slope is 5. And so now I can ask it sort of like the other way around. See, now I can take my entire f of x thing, ¿cierto? And since I identified that this is slope, the whole thing, ¿cierto? And this x is, what is my slope when x is what, or when x is 1, when x is 2, etc. If I take this whole thing and I equal it to 5, ¿cierto? It'll look like this. I can have 5 equals, whoops, 5 equals 2x plus, and I'm taking it from here, see? 2x plus 3 divided by x squared. All right, so this is a little different from part B, see? So let's compare it for a second. Let's really have clear what we're asking the function. For part B, we plugged in 1, and we're asking the function, what is my slope when x is 1, see? Down here on part C, I am asking, if my slope is 5, what are my x values? So like, where in my function is the slope 5? See? Where in my function is the slope 5? And because it's a quadratic, ¿cierto? It's something weird that probably looks like that, ¿cierto? It can have slope 5 in more than one place. It can have it here, it can have it there. Boom. So that's the sort of thing that's going on, see? Again, for part C, we're asking, when my slope is 5, what is my x value? Before we said, if my x value is 1, what is my slope? All right, so right now we're trying to see if the slope is 5, if the slope of 5 shows up more than once in our function, see? And so if I go ahead and plug in 5 here, I now need to get the value of x, see? Now, from here, all right, I think it's a little hard to solve it like by hand. I mean, it's possible, but I think it's pretty hard. And so what I would suggest, all right, in order to find the values of x, I would do a calc intersect sort of thing. See? So this right here is going to be y1. When I say y1, I make reference to this y equals over here. Okay. Over here, it's going to be my y1. And over this whole other thing is going to be my y2. See? And if I do calc intersect, I'm going to get the answer for my x values. All right. I have a quick video on the calc intersect trick that you can look it up. It's around there. I'm sure you'll find it. See? But if I go ahead and graph this, all right, there is my y1, cierto, the 5, and there's my y2. And as you can see, cierto, I'm just going to draw it out really quickly. See? As you can see, I have something that looks like this. I've got one line. I've got one line cutting that goes something like that, and then it goes like this. See? So that is f of x. Okay? And then over here, I have the famous 5, ¿cierto? This 5 here, the y1, right? And so how many times does it intersect? It intersects 3 times. Here, here, and here. So basically, trusting the process and everything and blah, 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 right? Actually, yeah. Trusting the process and everything and blah, 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 we can identify that. We can identify that my function f of x has a slope of 5 in 3 locations, ¿cierto? One of them is when it is tangent to L, ¿cierto? As we found in part B, it is tangent to L once, right? And then the other 2 times, it is some other parallel line, see? And so your answer would be 3 times, including L, or 2 other times besides L, see? You can get full credit just showing the graph, or you can also get super mega technical and find the x values, see? How would you find the x values? Well, you would need to find the coordinates of each of these 3 points, see? How can you do that? Well, what I would suggest is go over here, go to second trace, so you hit calc, and find the intersect, see? You find the intersect, whoops. Find the intersect, go ahead and use guess to pick which one you want to choose, or pick which one, yeah, pick which one you get the answer for. And there you go, writing down the x values. See, so for the first one, it would be negative 0.68. See, I'm not going to show you the rest of the calc intersects because I don't want to make this video super long. But as you see in the answer key, that is one way you can find it. See, one of the ways you can do it is showing all your other x values. I just showed you how. The other one is simply graphing it, which I think is more intuitive, finding the 3 points, right? And leaving very, very clear, as I said here, you either say that it is 3 times including L, right? As you can say here, you can say that it's 3 L's including L, or there are other 2, okay? Whatever's more intuitive, whatever works for you, that is number 11. Right, and now for number 12, we have that the cross-section of an arced entrance into the ballroom of a hotel is in the shape of a parabola. This cross-section can be modeled by part of the graph y equals blah. See, blah being that thing on the right side. Where y is the height of the arcway in meters at a horizontal distance, we have x meters. From the point O in the bottom corner of the arcway. All right, cool. So for part A, we have determine an equation for the axis of symmetry of the parabola that models the arcway. What the hell is axis of symmetry? So axis of symmetry in a parabola, which is the cool thing of a parabola, is that it's perfectly symmetrical. Okay, it can also be a little bit like your face. See, so you're in your face, you have one eye here, one eye here. You have one nostril here, another nostril there, ¿cierto? Whatever your smile, etc. I don't know. See, certain amount of teeth here, certain amount of teeth there. It is perfectly symmetrical. See, perfectly symmetrical. You have one eye, one nose, one nose. I mean, one nostril, one nostril. You know what I mean. See? And so axis of symmetry is no different than a parabola. See? If you make a line straight down from the middle, this distance from, say, here to here is the same as from here to here. The distance from here to here is the same as from here to here. All right? Because of the axis of symmetry of the nature of parabolas. So, how the hell can I find an equation, or how can I find the axis of symmetry, ¿cierto? Which x value is my axis of symmetry for the parabola? Well, well. Ladies and gentlemen, when you walk into the test for your IB exams, you're going to be walking in with your pencil, probably a pen as well, your calculator, your brain, your confidence, and your formula booklet. Okay? You have to get familiar with your formula booklet. You have to know what's in it, know what tools are in there, know what you can use, what you can't, etc. So if you go to your formula booklet and once you get familiar with it, you're going to see that for axis of symmetry, there is an equation you can use. It is right here on page number 5. All right? So axis of symmetry, as you can see here, is this. See? What it's basically saying is that if you have a parabola, ¿cierto? How do you know it's a parabola? Because it's squared. If you have a parabola, your axis of symmetry is going to be x equals negative b over 2a. See? What is b? What is a? A is the one that has x squared next to it. B is the one that has a single x next to it. See? And C is the one that's alone. So, my equation for the axis of symmetry is x equals negative b over 2a. So, for part A, I need to do negative b over 2a. So, what is b? What is a? Well, my function, right, is y equals negative 1.6 x squared plus 4.48x. So if I go ahead and I get really mean with you and I tell you, or I ask you, what is A, what is B, what is C? Well, you're probably going to tell me that A, ¿cierto? The one with the x squared next to it, is negative 1.6. For B, you would say 4.48. And for C, you would probably be like, wait, what? Here, my C value is technically 0. All right, it's not that it's, I mean, yeah, it's not there. And if it's not there, your C value is 0. Okay, just so that you know, that is how it works. Okay, that can happen with your B value as well. So careful with that. ¿Vale? But yeah, so your C value here is 0. In this case, it doesn't really matter, but just so that you guys know, okay, that is how it works. All right, cool. So if I go ahead and plug in negative b over 2a, I would be plugging in negative 4.48 divided by 2 times negative 1.6. How much is that? Let's see our calculator. If you ever need to plug in a fraction, ¿cierto? I suggest using alpha y equals. Alpha y equals brings up this menu. Press the first one. Boom, you now have a fraction and it's much easier to plug in. You don't mess up the double negatives and stuff like that. Yada, yada, yada. Boom, 1.4. So that means that, well, for part A, it's 1.4. And right here, I have an x value of 1.4. All right, that is part A. Cool. For part B, they say to prepare for an event, a square, okay, a square-based crate that is 1.6 meters wide and 2 meters high is to be moved through the archway into the ballroom. Wait, that doesn't sound like a square. I thought squares were the same dimensions. Alright, whatever, man. We've got a fucking crate. See, it's 1.6 meters wide and 2 meters high. It is to be moved through the archway into the ballroom, and the crate must remain upright while it is being moved. For part B, we need to determine whether the crate will fit through the archway and to justify our answer. Alright, so, guys, if you were to have to fit a crate through an archway, through which side would you try to do it? Would you try to do it through the left side? Would you try to do it through the right side? Nah, brother. You would try to do it right down the middle. Why right down the middle? I know it's intuitive, but put it in words. Why? You would do it right down the middle because it's where you have the most space. See, it's also where it's the most tall. Okay, so you will be putting it through the middle. See, now a lot of people here would say, 1.6 meters wide. Come on, oh, my acceleration is 1.4. Come on, they get a little bit tripped up on it. See, but notice if my square, if my crate is going right through the middle. See, let's say that it's something like this. See, I don't know the dimensions yet, but I don't know if it's gonna fit or not. But I'm gonna draw it like this for now. See, if it goes through here, see, the 1.6 meters wide, where would it be? A lot of people get confused. They think it's from 0 to 1.6 like this. But actually, the 1.6 meters wide is like that. That is the how wide my crate is. See? So how much to the left, or what is my x value here, and what is my right value there? That is the real question. So if it's going through the middle, and here it's 1.6, see, as I mentioned earlier, how much to this distance here is the same as this distance here. See? And because I'm doing 1.6, well, 1.6 divided by 2 gives me 0.8. So that means, hold on. That means that if my axis of symmetry is 1.4, it is going to be 0.6, like my x value is 0.6 over here on the left, and 2.2 on the right. Those are the dimensions for my x values of my crate. See? Now we just need to see if they're high enough, ¿cierto? Because this height here could be up here. See? It's something that I have to discover. This is just a drawing for convenience. So let's go ahead and plug in, right? Let's go ahead and plug in 0.6 for my f of x, 2.2 for my f of x, and see if it's taller, ¿cierto? Than my maximum here. See? So if I go ahead and plug in 0.6, ¿cierto? For f of x, so I'm going to plug in f of 0.6. It means that here, ¿cierto? I'm going to have negative 1.6 times 0.6 squared plus 4.48 times 0.6. So I whip out my calculator, I plug in 0.6, I do the whole thing, and I end up with 2.112. 2.112. All right, what does that mean? See, it means that at an x value of 0.6, this value here is 2.112. See? And how high is my crate? My crate is 2 meters high. And so this crate, I'm just going to draw it a little more accurate. See? This crate looks something like this. All right? So here, the crate fits because my maximum, ¿cierto? How high the arcway is at that point, ¿cierto? Is 2.112. But the height of the crate is just 2. And so it's below it. It's fair. I have a little bit of space where it doesn't touch. The crate fits. Okay? And because it's a quadratic and it's all symmetrical, if it fits through the left side, it's going to fit through the right side because this value here is the same as this value here. See? If you're not sure and you're nervous and you want to check, I totally respect that, ¿cierto? I'm going to go ahead and plug in 2.2 here. See if it's still below 2 meters. See? Or below 2.11, ¿cierto? So again, plug in, boom, it's the same value, ¿cierto? So that means, again, my crates is not touching. That means it's going to fit through my arcway. And that is how you would actually justify it, see? The very, very fancy way to do it is that, well, you show your work like this, and then you would say 2.112 is greater than 2. And because it's greater than 2, it doesn't touch. Doesn't touch. Crate fits. All right? That is how I would justify it, and that is number 12. All right, and now we have the last one, the weirdest one, I think, number 13. We have that Juliana plans to invest money for 10 years, okay, 10 years, in an account, paying 3.5% interest. Compounded in which way? Compounded annually. She expects the annual inflation rate, inflation, to be 2% per year throughout the 10-year period. Juliana would like her investment to be worth a real value of 4,000. To be worth a real value of $4,000. Compared to current values at the end of the 10-year period, blah, 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 she considers two options. The first option we have, make a one-time investment at the start of a 10-year period. Okay. And the second one is invest 1,000 at the start of the 10-year period and then invest an X amount into the account at the end of each year, including the first and last years. All right, cool. What the heck is going on? So for part A, we have for option 1, determine the minimum amount Juliana would need to invest. Give your answer to the nearest dollar. All right, interesting. So some of you, just by context, by reading this, probably already identified that it's a compound interest problem. Okay, the hint I can give you for identifying that is that it says interest here. See, so if it says interest, especially if it says compounded something, in this case compounded annually, those are big hints that this is probably a compound interest problem. So what you can do is pull out your formula booklet. See, here it is. Application Interpretations Formula Booklet. Go ahead and search for compound interest. See, here it is. I think it's page 5 if I'm not mistaken. It's page 3. See, it's even closer. This is the compound interest formula, okay? It is between the geometric stuff and percentage error. So, compound interest, here it is. I know it might look weird, for some of you it might even look new, okay? But the cool thing about compound interest is that it's very, very like methodological in the approach, okay? I'm gonna explain that in a second. What I mean by this is that you can notice I have 5 things. I have FV, PV, R, K, and N. See? K shows up in 2 places. It shows up here, shows up there. See? But it's 5 things I need. Dale? I need PV, which is present value. I need FV. Actually, let's just go in order. I have FV, future value. PV, present value. R, which is the percent. ¿Cierto? It's going to be a percent. K is compounding periods per year, and N is amount of years. See? You can absorb that from what it says here. Okay? So, let's go ahead and see it in action, right? So if I go over here and I go ahead and plug it like that, ¿cierto? What is FV? What is PV? What is R? What is K? What is N? Just by context, let's figure it out. See? So, let's read it again, knowing the compound interest formula, and see what we fill in as we go. See? So, Juliana plans to invest money for 10 years. One of these was time. One of these was years. Which one was it? N is the number of years. So N is going to be 10. N is 10. Cool. Let's keep going. Yeah. In an account, paying 3.5% interest. Okay, so interest over here is probably going to be 3.5. Blah, blah, blah. Compounded annually. Okay, there was something about it being compounded in a certain way. See, here it says number of compounding periods per year. Okay, that's just fancy math language for like how many times you're charging the thing or the account or stuff like that. Okay, and so for periods, the things that you can find, ¿cierto?, is annually, which is our case, which is k equals 1. The more common one is probably monthly, which would be, you guessed it, k equals 12. And lastly, you have quarterly. Okay, quarterly, quarts, 1/4. You have k equals 4. See, those are like the classic ones. I don't think you're gonna find anything else. The weirdest one, I don't think it shows up actually, but it might be bi-monthly, which is once every 2 months. So that would be k equals 6. Okay. Whatever, man. So for periods, you have those buzzwords: annually, monthly, quarterly, bi-monthly. Here, since we have it annually, we're gonna say that k has to equal 1. All right. Then we figure out that the inflation rate is 2%. Does the inflation rate affect my R? Does it affect my FPPV? Let's see what happens. All right, this thing here, it's probably like where they try to trap you in this exercise, okay? So I'm going to talk a little bit about inflation in a moment, all right? They later tell us that Juliana would like her investment to be worth a real value of 4,000. So to be worth a real value of 4,000. So that is what her investment would like it to be. So FV is going to be real value of 4,000. I'm going to talk about what real value as well means. Okay, so just give me a moment. And then for part A, it asks us to determine the minimum amount Juliana would need to invest. So that would be what she invests today. That would be PV. So PV is actually going to be what we're looking for. All right. So this right now is what I'm working with. All right. So let's figure out FV. Let's figure out if R gets affected by inflation, etc. And so the rule of thumb I'm gonna give you right now is that if you have inflation, it has to affect, or if you have inflation, you have to consider it at least once. I'm pretty sure you consider it only once, right? So that's like the rule of thumb I'm gonna give you, like consider it just once. See? And so here, the way in which I can consider it is because FV has to be the real value of 4,000. That means I need to change my FV cannot be just 4,000. See, it needs to be 4,000 converted to a real value. All right. How the hell do I convert it to a real value? What is a real value? A real value is when people talk about, I don't know, like a dollar from the 80s. How much would that be worth today? All right. That would be a dollar from the 80s brought into real value to 2023. All right. When people used to say like, "Oh, dude, with like $5, you could get like a full ass McDonald's meal and like a Porsche," you know, like they're talking about the real value of the dollar back in the day. So you know, back in my day, like a dollar was worth a lot more. ¿Cierto? Nowadays, a dollar is worth less in that sense. So yeah, okay, that's like real value. That's like when people talk about stuff in real terms, it's in respect to what it was before. See, it's always in respect to time. And so, because here we have a 2% inflation rate, I can go ahead and plop that in like this, 1.02. And for how many years? For 10 years, okay? So that is going to be the real value of 4,000, okay? The real value of 4,000 is whatever number I get here. So I pop up my calculator. I was actually doing it just now. We have 4,000 times 1.02 to the power of 10. That gives me that. See, so my FV is actually 4,875.977. All right. And so now that I considered it at least once, or I considered it once, actually, I'm going to change this rule of thumb over here. Consider it once, like somewhere, ¿cierto? My FV changes, my R doesn't. All right. An alternative, I'm going to say right away, ¿cierto? Because you're going to see in the answer key that it's actually like this. An alternative is that you don't change your FV, but you do change your R. See? So you would do 3.5% minus that 2% inflation. You end up with 1.5%. See? So that is another approach you can give. For me, it's more intuitive than what I just showed. See? To each their own. Fuck it. If there's inflation, consider it somehow. Only once. See? So my FV, as I said, turns into that. All right. So now let's go back to the formula I showed earlier. So the formula I showed earlier, which is this one here, cierto, with all the blue check marks, we're going to have that FV equals PV times 1 plus my interest rate thing divided by 100 times K to the power of K times N. So if I plug everything in, I end up with 4,875.977 equals my variable x parentheses 1 plus 3.5%. Actually, it's already in percent, so you can just leave it as 3.5 divided by 100 times 1. See? Why is it times 1? Because k is 1. Compounding periods. 100 times 1 is still 1. I know. But just to be organized and just to follow the process, see, I'm going to plug everything in. See? Yeah. So that is what we're trying to find. See? Now, I need to get x alone, right? So you can actually probably just divide by all of this shit, and it's going to work out. But I'm going to show a different trick. See, especially for compound interest, sometimes your x can be like up here, and it's much harder to solve. See? And so I'm going to give you a trick that always works. It's the calc intercept trick. I do have a video on this, but very quickly, this is going to be y1, and this whole thing is going to be y2. What do I mean by this? In your calculator, you have y1 and y2 over here as lines. See? So if you put them as lines and find wherever they meet, that is going to be whatever makes that equation true where they intersect, and that is going to be your value of x. See? So it's going to make a little bit more sense in a second. Give me a moment. Let me go ahead and put that fraction here. Blah, 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 blah. Go ahead and graph. Boom. My window is nice enough already. I can see the intersection. I go ahead and do calc intersect by pressing second trace. Hit that calc button. I go to intersect. Boom, boom, boom. Kapow. That's my intersection. See, so you can see that what I got, cierto? Basically, my whatever was 3,456.607. 671. See, 6718, comma, whoops, 4875.977. See. Now I do have a video explaining like how to read this result, but very quickly or intuitively, cierto? This number showed up once somewhere. See? It showed up here. So that is like my y1, okay? My y2, or the number that I'm missing, cierto? This one here doesn't show up anywhere else. So it has to be this one, all right? That's sort of like the intuition that I'm going to give you for now. So for part A, the minimum that she needs to invest is 3,456.676, whatever, man, this number, see? And what amount? In dollars, see? So this is the minimum amount that Juliana would need to invest for part A. Phrasing it like this is enough justification. Make sure you show how you got FV, okay? So that is for part A. For part B, it is very fucking weird, okay? But I'm gonna try to show you guys the most intuitive way possible, all right? So for option 2, we need to invest 1,000 at the start of the 10-year period, and then invest X into the account at the end of each year, including the first and last years. And we need to find the minimum value of X that Juliana would need to invest each year. Give your answer to the nearest dollar. Now, when it says each year, this is a massive hint, okay? Because the compound interest that we just did is just once, ¿cierto? In fact, option 1 is make a one-time investment. For investing each year, it's a little bit different, okay? And now the compound interest formula helps, but it's not everything we need to use, okay? If you go to your calculator and you go to this thing called finance and apps, okay, you press apps, this purple button, and you press finance, here you have the TVM solver, okay? And the TVM solver is basically just the compound interest formula, but it has an added thing. It has the PMT, okay? And the PMT, very intuitively, is exactly what you need to invest each year. See, it's something about each period, each year, stuff like that. Option 1 was one-time investment. Option 2, the moment you see something about each year, see, each year, you need to be thinking PMT, okay? And how do you find PMT? You need to use the finance app, all right? And so here, the intuition that I'm going to share is that you plug everything in, all right, except the PMT, and then you're going to find the answer, all right? And so in this case, see, it's very similar to part A, but it has one small difference, okay? So the first thing we're going to do, okay, is that your FV has to be the same, okay? Because option 1 has to be at least the same or better than option 2, and it's the future value corresponding to this here, see? Actually, that's like the stronger reason, see? The FV comes from here, from the inflation thing. My present value, my present value comes from here. Because Juliana invested 1,000 at the start of the 10-year period, that means she starts off by losing a bit, okay? And I know this is kind of weird, like why the hell is it negative, cierto? Well, because now we're dealing with an each year investment, cierto? That is how it's gonna end up turning positive, stuff like that, etc. See? And so just go with the flow for now. When you have PMT and she invests at the start of the year, and we are for the perspective of Juliana, that means she is losing 1,000 at the start of the year. See? So, negative 1,000. See? The R stays at 3.5. because the inflation was already considered for FB, ¿cierto? I am considered inflation at least once, so I can leave the 3.5 as 3.5, K is 1, N is 10, see? And PMT is going to be calculator, all right, quite literally. So PMT is what we're looking for. PMT is going to be your X value, right? And the calculator is going to help you find that. So I go ahead and plug everything in. N is 10, my percent is 3.5, my PV is negative 1,000, my PMT, we leave it at 0. That's what the calculator is going to find. You don't need to plug in X, actually. It's not necessary. You can just leave it at 0. FV is the one we found earlier. And these two are just like K and N, basically. I mean, sorry, it's just K. See? You leave them both as 1. Forget about it. PMT, end or beginning. Because it is at the end of each year, as it says there, that means PMT is going to be end. See? So we press enter. Nothing really changes because we're just plugging in data. See? We need to go again to the apps finance and go to TVM PMT. See? So this is what calculates PMT for us given the stuff we plugged in. So what is PMT given all the stuff we plugged in? Boom. 295, 3935. So for part B, the minimum value of X that Juliana will need to invest each year is negative 295.3935. Now, this right here is almost correct. It is incredibly close to being correct. What is wrong with this answer? Well, what is wrong with this answer is that you have a negative 295. All right. Because it is an amount that Julian will need to invest, okay, each year, technically it's positive. See? Why is it negative up here? You might be thinking, like, what the hell, you're contradicting yourself. Well, not really. See? This initial calculation, see, the initial calculation is from the perspective of Juliana. Okay, Juliana starts losing $1,000. Boom. So you leave it like that, and it's also negative 1,000 because when you're dealing with PMT, ¿cierto? When you're dealing with PMT, you have to look at it that way, ¿cierto? If you're not looking at it that way, if you don't have the PMT thing going on, it's like in part A where it's all positive and you're happy and you don't worry about it, okay? But because there's PMT, because there's each investment per year, and because you're facing it from the perspective of Juliana, you do negative 1,000 for PV, okay? There's an alternative way where it's like from the perspective of the bank, and it's actually negative FV and positive PV, see? Again, there's like 14 million different ways to face this. Actually, if you look at the answer key, there's like 3 methods for part A, there's like 3 methods for part B, like actually there's just 2. But still, it's crazy, right? It gets nutty. There's a lot of ways to face this, okay? And so I hope that what you take away from this is sort of like the general intuitions, see? First of all, the intuition of what the compound interest formula even is in the first place, ¿cierto? Usually you have 4 out of 5 of these variables, right? And so you need to find just one. The intuition that if you have inflation, you have to consider it just once, whether it's an FV or your R, ¿cierto? And also, when you have PMT, shit gets weird. And you really have to think about having a negative PV and thinking about the perspective of Juliana. See, that is the only scenario where you would have like a negative for PV, at least in what I have encountered. So that, ladies and gentlemen, would be number 13, and that would be paper 1, 2022, if I'm not mistaken, time zone 2. I hope it helped. Take it easy.